Welcome, weary traveller, as we prepare to drift across the boundless ocean of time, back to a Genesis veiled in fire and stardust. Tonight, we journey to the very dawn of our world, to an era so ancient, its existence feels like a forgotten dream. As we gently let our minds wander, a curious thought might emerge from the cosmic ether. What if the earliest chapters of Earth's grand narrative are not simply lost to the relentless currents of deep time, but rather intentionally veiled, whispered into oblivion by the planet itself? Imagine for a moment, shedding the familiar embrace of blue skies, the tranquil depths of oceans, and the verdant hush of green valleys. 4.5 billion years ago, our nascent world was utterly unrecognizable, a raw, untamed entity. This was the Hadean Eon, a period aptly named for the fiery underworld it resembled. Earth was a restless, glowing furnace, a vast, shimmering sea of molten magma, stretching to every smoky horizon. Its nascent surface was relentlessly hammered by falling asteroids and cosmic debris, each impact a thunderous punctuation mark in its violent birth. The very air shimmered, thick with searing heat and poisonous vapors, a choking shroud that clung to the incandescent sphere. Volcanoes, not merely active but alive, roared without pause, their fiery breath painting the sky with a perpetual, ominous glow, like the heart of a colossal, untiring forge. One might instinctively perceive this primordial landscape as utterly empty, hostile, devoid of any possibility of life. This, we are told, is the conventional, accepted version of our planetary infancy. But let us pause and allow a more contemplative question to unfold in the quiet chambers of our minds. If evidence of something extraordinary, something truly unexpected, did exist back then, a fleeting whisper of intelligence perhaps, would the very fabric of our world even permit us to uncover it now? The ancient rocks of that tumultuous age, the potential keepers of such secrets, have been endlessly melted, remade and swallowed back into the Earth's churning mantle. It is as if the planet itself, with an almost deliberate hand, diligently scrubbed away its earliest diary, leaving behind a silence so profound it feels too clean, suspiciously clean. So, let us engage in a gentle game of cosmic imagination. Picture yourself, if you can, standing at the very edge of those vast, incandescent magma seas, watching silent fire rain down from the unfathomable heavens. Feel the distant, resonant thunder of colossal collisions, the searing hiss of stones surrendering to liquid heat, and then allow yourself to imagine, not on the surface but beneath it all, woven into the very fabric of that fiery chaos, a secret, a forgotten visitor from an unknown realm, a fleeting trace of intelligence, erased so completely that it vanished before the very concept of history had even begun. Could it be, or is it merely the universe's elaborate way of stirring our deepest curiosities? Before we slip deeper into this ancient reverie, I invite you to make yourself utterly comfortable. Allow the gentle darkness to wrap around you like a soft blanket. Feel the quiet hush settle as we prepare to journey back, far, far back, into the firestorm heart of the Hadean. Listen closely, for in the deepest silence, Earth itself might be whispering. Search if you dare, but be careful what you seek. Long before our Earth cradled vast oceans, before majestic mountains pierced the sky, before even a single grain of familiar soil existed, there was only dust. Not the mundane dust that gathers softly in sunlit rooms, but cosmic dust, glittering fragments shed from the hearts of ancient, long-dead stars. These motes of creation carried within them the ashes of supernovae, the faint, echoing whispers of stellar furnaces that had lived and died in brilliant cosmic ballets, eons before our own sun had even sparked into being. Picture, if you will, a swirling golden disk of these particles, suspended around a newborn star, a celestial haze, spiraling in an impossibly slow, graceful motion, where countless fragments gently collided, clumped together, drifted apart, and then rejoined once more. This was not chaos, for chaos's sake. Rather, it was the grand workshop floor of creation, a slow-motion mixing bowl, where gravity, an invisible, patient hand, tirelessly stirred the primordial ingredients. Out of this luminous haze, something truly extraordinary was about to unfold. The very genesis of Earth, this vibrant living world, began its story within that rotating nebula of gas and dust, known to astronomers as the protoplanetary disk. At its heart, a young sun glowed radiant but still finding its equilibrium, sending gentle waves of heat and light outward into the swirling disk. Closer to this nascent star, the heat allowed only resilient metals and rocky minerals to condense out of the hazy cloud. Farther away, where the sun's embrace was softer, ices and gases accumulated in vast, ethereal clouds. Earth's story, our story, belongs to that inner, rocky zone, a realm forged in fire and silicate dreams. Imagine those tiny grains of silicate, iron, and nickel as the precious flour and sugar in a cosmic recipe. Individually minute, they possessed a subtle, inherent stickiness. As they gently bumped into each other, drawn by the whisper of gravity, they didn't always drift apart. Instead, they began to cling, forming ever so slightly larger clusters. These delicate clusters grew into cosmic pebbles, then into small boulders, and eventually into kilometer-sized planetesimals, the very building blocks of worlds. Each gentle collision released a tiny pulse of heat. Each union made the growing bodies heavier, imbuing them with a greater gravitational pull, an enhanced ability to draw in their cosmic neighbors. It was a snowball fight in reverse, a ballet of accretion where fragments were not flung apart, but endlessly, persistently drawn together, weaving themselves into a larger destiny. This patient, ceaseless process of accretion continued for millions upon millions of years. Imagine, if you will, the vastness of early space, littered with countless rocks playing an eternal slow-motion game of bumper cars. Some collided with devastating force, shattering into a million fragments, returning to the stardust from which they came. Others, more fortunate, fused together, forming progressively larger proto-planet. Among these burgeoning worlds, in the very orbit we now serenely occupy, one growing body began its arduous journey toward becoming Earth. Its formation was neither smooth, nor gentle, nor peaceful, but little by little, impact by impact, what would one day become our home pulled itself together, molecule by molecule, rock by rock. If you could have observed this cosmic dance from a vantage point high above, you might have witnessed something akin to dough kneading itself, each collision folding new precious ingredients into the growing mass, mixing iron here, silicates there, and even water-bearing minerals carried in from the colder, more distant reaches of the disk. At a certain pivotal point in this grand cosmic ballet, gravity transcended its role of merely gathering material. It began, with an invisible, profound touch, to reshape the very interior of this growing world. Heavier elements, such as iron and nickel, jostled and heated by countless impacts, began to melt. Like dense liquid dreams, they trickled downward, sinking toward the planet's heart, to form a dense, metallic core. Simultaneously, lighter materials, silicates, magnesium, aluminum, gently floated upward, destined to become the Earth's expansive mantle. This fundamental separation, a process scientists call differentiation, was a planetary milestone of immeasurable significance. Without it, Earth would have remained a uniform, inert lump of rock, a cosmic sphere without personality. With it, our planet became layered, complex, and vibrantly dynamic. You might think of it as a cake baking from the inside out, the heavy ions sinking like rich, melted chocolate chips to the bottom, while lighter, airy sponge gently rose to the top. Or if you prefer a more whimsical image, imagine Earth proudly announcing to the cosmos, "I've got a heart of iron," literally. The formation of this iron heart was not merely a structural quirk, it was destiny etched in molten metal. This colossal spinning core began to generate a powerful magnetic field, an invisible shimmering shield that would one day protect the delicate young planet from the relentless, stripping breath of the solar wind. It was a feature no cosmic instruction manual could possibly overlook, a kind of elegant, interstellar insurance policy. Without this protective cloak, the sun's relentless radiation might have stripped away Earth's nascent atmosphere long before life had even a glimmer of a chance to emerge. But with it, Earth was equipped not only with layers of rock, but with a magnificent, silent defense against the storm. Some might attribute this solely to the elegant, unfolding laws of physics. Others, observing the profound symmetry and exquisite timing of this arrangement, might whisper, perhaps it looks suspiciously like planning, a subtle underlying intention in the grand design of the cosmos. But let us not rush this ancient narrative. At this stage, Earth was still an infant, a volatile, energetic toddler in the nursery of the solar system. The colossal collisions had not yet ceased. In fact, one of them was destined to be so immense, so transformative, that it would give birth to our moon, a Mars-sized body, often referred to as Theia, crossed paths with proto-Earth in a cosmic near-miss that, in the grand scheme of things, was no miss at all. The ensuing collision was nothing short of apocalyptic. Rock vaporized into incandescent gas, molten material sprayed violently into orbit, and for a brief, terrifying moment, Earth may have worn a fiery halo of shimmering debris out of that incandescent ring. Through the same slow, patient clumping and gathering that had built Earth itself, our celestial companion, the moon, was born. It was not a quiet birth, but a necessary one. The moon's profound gravitational pull would go on to stabilize Earth's axial tilt, ensuring seasons that were not wildly unpredictable, but regular, predictable, and ultimately survivable. Again, one might say, merely physical, but if you squint, allowing your imagination to wander at the elegant symmetry of this celestial dance, it begins to resemble a meticulously choreographed ballet, a cosmic dance with a purpose far grander than mere charm. As Earth continued its tumultuous growth, it did more than just sort its elements and capture a celestial companion. It became a vibrant crucible for chemistry, a grand laboratory where elements mingled and reacted under unimaginable conditions. Heat, generated from the radioactive decay within the mantle and from the relentless fury of impacts, kept the surface largely molten. Yet, deep inside, the planet's layers began to organize with increasing complexity. The core, dense and metallic, hummed with energy and magnetism. The mantle, though solid on human timescales, churned slowly, like impossibly thick, cosmic taffy, setting the stage for the profound tectonic movements that would one day sculpt our continents. These vast, slow motions would in eons to come recycle carbon, raise majestic mountains, and create the dynamic geological stage upon which vast oceans and the intricate tapestry of life would eventually emerge. None of this, the textbooks confidently state, was written in advance. And yet, the sheer coincidence of each ingredient aligning so perfectly, a spinning molten core, a dynamic churning mantle, a stabilizing tidal moon, invites a deeper question. Was this merely chance, or was it a cosmic recipe designed with astonishing precision to yield something very specific? A touch of cosmic humor, if you allow it, gently slips into this narrative here. Because when you imagine Earth forming, you can almost picture not just rocks colliding, but a bustling, chaotic cosmic kitchen. Dust as the flour, sparkling metals as the sugar, the immense heat as the oven, and gravity as the invisible, patient baker's hand. Earth in this whimsical view wasn't a ready-made product, but a slow, monumental bake. The core settled like a dense, rich caramel center. The mantle rose like a light sponge, and the crust eventually cooled like the first delicate layer of frosting. And perhaps the planet itself, if it could speak through the eons, would lean over and whisper with a knowing grin, "I was baked at 5,000 degrees Kelvin. Do not taste still rather hot." The remarkable truth is that all this intense activity, the swirling dust, the thunderous collisions, the melting and separating of elements, was not unique to Earth. Dozens of protoplanets formed in the early solar system, each a testament to the raw power of accretion. Many were shattered, violently ejected from their orbits, or absorbed into larger bodies. Some remain today, familiar celestial neighbors like Mercury, Mars, and Venus. But only Earth, through this vast cosmic lottery, ended up with the particular, astonishing blend of conditions that would later nurture vast oceans, stable continents, and the miraculous complexity of biology. Some scientists attribute this solely to cosmic luck. Others, observing the profound improbability of such a confluence, feel a subtle chill of cosmic conspiracy, a sense that something more than randomness was at play. Was Earth somehow selected? Gravity merely rolled the dice until a habitable world serendipitously appeared? Or was there some deeper, unseen order gently nudging the process along toward a specific outcome? The idea of cosmic order, it must be noted, doesn't necessarily require a blueprint stamped with life inside. It may simply imply that the fundamental laws of physics themselves act like an exquisite recipe book, given the right ingredients. Hydrogen, carbon, oxygen, and the vast expanse of time, planets will inevitably form. Given enough planets, one will, by the sheer force of probability and the elegance, physical laws, find itself in the precise orbit, with the perfect chemistry and with the indispensable companion moon. And when that cosmic alignment occurs, the stage is set, the curtain ready to rise. In this profound view, Earth is not a cosmic accident, but an inevitability, like the way flour, sugar, and heat, when mixed long enough, will inevitably yield bread. And yet, inevitability is not quite the same as pure randomness. It carries the subtle, fragrant whisper of intention, even if no discernible hand is ever seen. Meanwhile, deep within the heart of proto-Earth, the planet's interior continued its profound evolution. The newly formed iron core didn't just create a magnetic field, it generated immense heat, keeping the overlying mantle actively churning. That restless, dynamic mantle gave Earth its distinctive, ever-changing geology, a planet that would never sit still, a world that could recycle its crust, keep its surface perpetually young, and constantly refresh its chemistry. Compare this vital dynamism to Mars, which cooled more quickly and became geologically sluggish, its interior solidifying into a static state. Compare it to Mercury, stripped of much of its mantle by ancient impacts. Earth, by profound contrast, remained in a state of vibrant internal motion. It possessed an abundance of energy to spare, a constant internal fire. It had, in the words of some whimsical cosmic chef, kept the oven on. By this momentous stage, Earth's mass had grown sufficiently to anchor a nascent atmosphere. It wasn't breathable, not by us, not yet, but it was a vital beginning. Volatile elements, gases trapped within the planet's interior, began to outgas from countless volcanic vents. Carbon dioxide, nitrogen, water vapor, later comets and asteroids, carrying precious cargo of water and complex organic compounds from the colder reaches of the solar system, would add more to this growing atmospheric brew. Already, the subtle nascent seeds of future oceans, clouds, and intricate chemistry were being sown. This was not yet the gentle Earth of tranquil blue skies, but it was a colossal body, steadily readying itself, carefully storing ingredients for a future recipe of unimaginable complexity. If Earth could speak again, perhaps it would mutter with a satisfied sigh, "I'm marinating." There is something almost comically profound in imagining rocks as ingredients and colossal impacts as a chef's vigorous whisk. But behind the gentle humor lies the staggering, awe-inspiring truth. Every collision, every molten flow, every sinking iron droplet shaped the magnificent planet we now call home. And the longer one follows this intricate chain of cause and effect, the harder it becomes to dismiss the elegant, overarching pattern. Out of simple stardust came a planet shielded by a magnetic field. Out of violent chaos came a moon that stabilizes climate. Out of molten rock came intricate layers that recycle carbon. Coincidence, stacked upon coincidence, until the sheer weight of these coincidences began to look suspiciously like design, as though the universe wasn't merely rolling dice, but with a subtle, unseen hand, stacking them in a specific, purposeful way. Of course, the rigorous voice of science remains cautious, ever grounded in observable fact. The physics of accretion, differentiation, and planetary dynamics are meticulously understood. They require no guiding hand, no divine intervention. And yet, when you lie awake in the quiet of the night and allow your imagination to paint the silent glitter of dust grains, spiraling around a newborn star, the profound improbability of one of those clumps becoming a world as rich and vibrant as this one, it is hard not to surrender to a deeper wonder. What if the very laws themselves are the design? What if gravity is the spoon, nuclear fusion the oven, chemistry the cookbook, and Earth the improbable, yet perhaps inevitable, loaf of bread, baked by the cosmos itself? By the time Earth had settled into its magnificent, layered structure with its dense core, churning mantle, and fledgling crust firmly in place. It had become far more than just a rock. It was an engine, a living, breathing entity. Heat circulated through its deep interior, a magnetic field wrapped it in an invisible cloak of protection, and a majestic moon orbited in graceful, silent partnership. It was not yet the Earth of vast oceans, whispering forests and drifting clouds, but it was Earth in its very essence, a planet uniquely balanced, armed with shields, stirred with internal energy, and carrying within its very being the ancient memory of stardust. It had not yet cooled sufficiently to host calm, stable surfaces. That part of the story, the true beginning of the Hadean, patiently awaited its turn, but in the deep interior, the cosmic recipe was complete. The planetary cake was baked, and the universe seemed to pause, perhaps with a sly, knowing grin, and whisper, "Now let's see what this one can do." There are chapters in Earth's unfolding history that read like lyrical poetry, filled with the serene beauty of oceans and the majestic grandeur of mountains, the slow, balletic drift of continents, and the intricate dance of life. And then there is the Hadean Eon, a chapter that reads less like a gentle lullaby and more like the roaring cover of a heavy metal album. 4.5 billion years ago, Earth was no gentle cradle of nascent life, but a blazing anvil in the fiery heart of the solar system, a place so utterly hostile it almost defies imagination that this very same world, now covered in emerald forests and winding rivers, could once have been such an inferno. Imagine, if you dare, standing on a surface that isn't solid ground at all, but a vast, shimmering ocean of molten rock. The crust, if one could even bestow such a gentle term upon it, was a thin, temporary skin, stretched precariously across these boundless seas of magma, lakes of incandescent lava boiled and churned, mountains of fire erupted without pause, their fiery breath echoing across the void, and rivers of liquid stone flowed like molten blood across the planet's incandescent body. There were no continents, no tranquil seas of water, no soft soil beneath your feet. Earth was naked, stripped bare to its fiery essence, a sphere of primal, molten chaos, wrapped in a poisonous, glowing shroud. If there were gods of creation observing this tumultuous beginning, they might have leaned in, captivated, and whispered, "Let's test this one in the forge." The Hadean was an era defined by extremes, a symphony of raw, untamed power. Temperatures on the surface soared to thousands of degrees Celsius, hot enough to melt iron, hot enough to make solid rock flow like thick, incandescent honey. So hot, in fact, that even the air itself was infused with vaporized minerals, mingling with the atmospheric gases. This was no breathable atmosphere, no gentle blanket of nitrogen and oxygen. Instead, the sky itself was a choking, heavy brew of superheated steam, carbon dioxide, sulfur compounds, and ammonia, thick, glowing with residual heat, a toxic, shimmering veil that trapped the planet's internal fury below. To breathe here would have been to inhale instant poison. To attempt to walk here would have been to sink into an inferno. And yet, out of this terrifying crucible, the very foundations of the Earth we know today were being painstakingly laid. As terrifying as it sounds, this was not merely destruction, it was a profound act of creation. The planet was relentlessly hammering itself into its magnificent, enduring volcanoes were omnipresent, a constant roaring presence. Imagine a world where every horizon is perpetually lit with furious eruptions, plumes of ash and fire painting the sky with an unending, dramatic spectacle. The ground beneath trembled not occasionally, as it does today, but ceaselessly, as vast quantities of molten rock surged upward, broke through the fragile crust, and poured across the surface in incandescent rivers. Whole regions of the planet melted and remelted, reshaped with every surge of internal energy. Mountains of fire rose, only to collapse again into swirling rivers of liquid stone. Landforms barely had time to exist before they were consumed by the planet's restless fury. It was geology in its most frantic, untamed form, a planet rehearsing its profound lines by shouting them at the cosmos. Today we perceive volcanoes as spectacular, but relatively rare events. On Hadean Earth, they were the background noise, the rhythmic drumbeat, the very pulse of the world. Earth might have said, if it possessed a wry sense of humor, "I don't do calm, I do lava." The atmosphere was no less dramatic, a swirling, toxic masterpiece of planetary self-expression. Gases streamed constantly from innumerable volcanic vents, belching out superheated steam, carbon dioxide and sulfur compounds that mixed into a haze so incredibly dense it might have given the entire sky a perpetual reddish-orange glow, like a sunset that never truly set. Lightning crackled incessantly through the thick, turbulent clouds, fueled by constant atmospheric upheaval. Raindrops, if they even managed to coalesce and form in such an inferno, evaporated into steam long before reaching the scorching ground. In many profound ways, the air was less like a sky and more like an ethereal extension of the molten planet itself, a vast ocean of gas, swirling above an even vaster ocean of fire. Some scientists refer to this time as the ultimate planetary greenhouse, but that phrase perhaps sounds almost cozy. In reality, the Hadean atmosphere was a suffocating chemical cloak, one that ensured no fragile chemistry of life could even dream of beginning just yet. And yet, strangely enough, that same hostile atmosphere was an integral part of the grand experiment, holding in vital heat, recycling essential gases, and ensuring the planet remained dynamically alive. Was it mere chance, or was the universe meticulously setting up the precise laboratory conditions for something far, far more profound? There is an image that resonates deeply, one impossible to resist. Earth as a colossal forge, the kind a blacksmith uses, but on a planetary scale. Except here, the hammer was gravity itself, the fire was the planet's own internal heat, and the anvil was the vast, indifferent expanse of space. The Hadean Earth was not simply chaotic, it was a dynamic, purposeful workshop. Heavy iron was sinking to its core, ancient rocks were melting and reforming, diverse minerals were meticulously sorting themselves, and intricate chemistry was being stirred at unimaginable scales. Every eruption, every plume of gas, every boiling sea of magma was part of the same relentless process, the profound hardening of a planet's very identity. It was noisy, fiery, and utterly hostile, but it was also undeniably necessary. Without this furnace stage, there would have been no continents later, no tranquil oceans, no stable crust for life to eventually walk upon. Earth was, quite literally, being tempered, forged in the crucible of its own making. It's almost comical to imagine, isn't it? Picture Earth speaking with a raspy, booming voice, shouting over its own furious eruptions, "Don't mind the noise, celestial neighbors, I'm still preheating." If planets were cakes, this was the batter stage, bubbling furiously in the oven, splattering everywhere, not remotely ready to serve, or even contemplate. Anyone who dared to peek inside might have slammed the cosmic oven door shut again, muttering, "Not edible yet." And Earth, if it could, would have laughed, a deep rumbling planetary laugh, spraying a fountain of incandescent lava as a fiery punctuation mark. The surface itself was never still, never at rest. Picture vast, incandescent oceans of lava flowing like slow, molten rivers, solidifying briefly at their edges, before cracking and breaking apart again, consumed by the ceaseless internal heat. Imagine islands of nascent rock forming, trembling with the planet's internal tremors, then gracefully sinking back into the molten sea, reabsorbed into the fiery depths. If you could have hovered above it, the entire planet would have appeared vibrantly alive, a shifting, writhing body of molten muscle, flexing and twisting with raw, untamed power. The crust that did manage to exist was thin and fragile, cracking constantly, consumed as quickly as it formed. Stability was an impossibility. Permanence was a cosmic joke. The Earth of the Hadean was an improvisation in fire, rewriting its own incandescent script, minute by minute, moment by moment. No geologist today could ever hope to find much of it intact. It was as though the planet had made a silent, profound promise. No one will remember me like this. I will erase these fiery scars before anyone can read them. And yet, even in this raging inferno, the first subtle hints of order were being painstakingly born. Out of the churning magma, tiny, resilient crystals began to form, minute fragments of minerals tough enough to survive the unimaginable heat, resistant enough to endure for billions of years. Some of these, such as the humble zircons, still exist today. Tiny, indestructible witnesses that whisper across the eons. Yes, Earth was once this hot, this wild, this chaotic. These ancient crystals are like embers left behind from the great planetary fire, profound proof that beneath the chaos, there was, even then, a nascent underlying structure. They are the first survivors, the first storytellers of the planet's deepest part. And if you could hold one up to the light, you would literally be holding a fragment of hell, cooled to a profound, enduring silence. The Hadean's atmosphere, for all its toxic poison, was also surprisingly full of potential, a grand experiment in planetary chemistry. Superheated steam condensed and evaporated in endless cycles, heat and rain playing out ceaselessly across the molten landscape. Carbon dioxide built a thick, insulating greenhouse, ensuring that the planet did not cool too fast, maintaining its fiery dynamism. Sulfur gases painted the air with a myriad of chemical possibilities, a vast, complex palette for future reactions. From a human perspective, this environment was utterly unbearable, an instant death trap. From a cosmic perspective, however, this was a vibrant, indispensable chemistry class. Earth was not failing, it was experimenting, learning, evolving. Every cloud, every droplet, every volcanic plume was part of a long, arduous rehearsal for what would one day become a habitable sky. It was ugly, violent, and messy, yes, but so is any workshop when the masterpiece is still in progress, still being forged in the crucible of creation. Think of it this way. The Hadean was Earth's rebellious teenage phase, loud, moody, unpredictable, covered in volcanic acne, blasting toxic fumes like an adolescent's bad cologne. If planets kept yearbooks, Earth's Hadean photo would certainly not be flattering. And yet, this was the tumultuous stage where its very personality was forged. The fiery heart, the restless, churning mantle, the thick, dynamic atmosphere, all of it was set, defined and refined during these foundational years. Without them, there would be no later elegance, no serene balance. Earth had to be a monster before it could become a home, enduring its own primal fury to birth a future of untold beauty. And here lies the subtle philosophical twist. If you gaze upon the Hadean with the objective eyes of science, you perceive natural processes, the inevitable consequences of fundamental physics and chemistry. But if you allow yourself to look with a touch of imagination, with a whisper of wonder, you see something else entirely. You see a trial, a profound test, a cosmic furnace where the universe was meticulously forging a candidate for future habitability. Not every planet passed this rigorous test. Venus, our fiery neighbor, retained too much heat and became a runaway greenhouse, a blistering inferno. Mars, by contrast, cooled too quickly and lost its internal dynamism, becoming a static, barren world. But Earth lingered in the precarious middle, cooking hot but not too hot, volatile but not too sterile. It was as though the Forge Master, the universe itself, was subtly adjusting the bellows, testing, tweaking, waiting for the perfect balance to appear. And when Earth finally emerged, scorched and glowing, it was ready for the next, equally dramatic step in its magnificent transformation. Of course, if you could truly travel there, you wouldn't last a single second. Your shoes would melt instantly, your lungs would fill with searing poison, and your very shadow would be erased by the incandescent glare of molten rock. But if you could stand just out of reach, in a dimension of pure observation, you might feel not fear but profound awe. You would witness a world alive in a way ours no longer is. A world where fire was the dominant language, where gas was the very breath of existence, where stone flowed as fluidly as water. You might laugh nervously at the sheer, overwhelming spectacle and whisper, "This is insane." And Earth, through the roar of its eruptions, might rumble back, with a knowing, fiery wisdom. Insanity is how masterpieces are born. So when we speak of the Hadean Earth as hellish, we are not exaggerating the sheer scale of its primordial fury, but neither are we telling the whole, nuanced truth. It was hell, yes, but it was also a workshop, a forge, a grand rehearsal. It was the necessary chaos before the profound calm. It was Earth flexing its colossal muscles, burning away weakness, establishing its iron heart, its fiery mantle, its restless, dynamic surface. It was Earth proving itself to the universe. With every thunderous eruption, I can take the heat. I can survive the fire. I am ready to become more. And in the end, that is precisely what the Hadean truly was. Not just destruction, but profound preparation. The cosmic blacksmith's ultimate trial by fire. After the incandescent fires of the Hadean had sculpted Earth into a restless globe of molten seas and erupting mountains, one might logically assume the planet had earned a moment of serene peace. But the universe, it seems, does not hand out tranquility so easily. Around 4.1 to 3.8 billion years ago, Earth entered one of the most violent, yet paradoxically formative chapters of its existence. A time when the very sky itself seemed to turn against it, when the heavens rained stone and ice in a relentless, unforgiving storm that endured for hundreds of millions of years. It is known in scientific circles as the Late Heavy Bombardment, but that phrase sounds almost polite, as if the cosmos merely threw a fleeting tantrum. In truth, it was less a tantrum and more an unending apocalyptic barrage, a cosmic hailstorm in which asteroids and comets hurled themselves at Earth with a force beyond human imagination. Each one arrived not as a gentle visitor, but as a hammer, a torch, a potential gift-wrapped disaster. And yet, hidden within this storm of pure violence were the seeds of profound possibility. Was this bombardment an act of war by the universe, or a celestial delivery service dropping off the raw, indispensable ingredients of life itself? Imagine looking up, if looking up had even been possible without instant vaporization. The sky would not have been serene, filled with the gentle twinkle of distant stars. It would have been a terrifying canvas, perpetually streaked with blinding light, fiery trails cutting through the darkness as colossal rocks from the outer reaches of the solar system hurtled inward, drawn by Earth's burgeoning gravity. Some were the size of houses, others the size of majestic mountains, each impact releasing more energy than thousands of nuclear weapons, carving craters so vast they made mountains look like mere anthills. Oceans of nascent rock, boiled anew. Vast, incandescent scars stretched across the planet's tender skin. The moon, smaller and closer in those ancient days, was struck just as relentlessly, its face forever scarred into the cratered silent mask we gaze upon today. If the Earth could have spoken during this brutal era, it might have groaned, "Is this really necessary?" Only to be answered by yet another incoming fireball, streaking across the toxic sky. To stand on the surface would have been to stand in a perpetual war zone, except the enemy was not one, but countless, arriving from every direction, relentless, indiscriminate, and utterly merciless. Yet, as catastrophic as it sounds, this storm of relentless destruction may have been exactly what Earth so desperately needed. For within those asteroids and comets was not only barren rock, but precious water, locked within ancient ice, and vital carbon, bound in minerals, and even complex organic molecules, subtly forged in the distant furnaces of earlier stars. With each thunderous impact, not only did devastation rain down, but so did the indispensable ingredients of future oceans, the intricate chemistry of future cells, the very potential for life itself. It is an unsettling yet profoundly beautiful thought that the very projectiles that scarred the planet's nascent face may also have seeded it with the promise of life, weapons and gifts wrapped together, destruction and creation delivered by the same singular blood. Earth might have muttered through the incessant roar of impacts, "I'm being smashed to pieces, but these deliveries are promising." Scientists continue to debate the precise cause of this colossal bombardment. Perhaps the giant planets, Jupiter and Saturn, shifted ever so slightly in their majestic orbits, disturbing vast belts of asteroids and comets, and sending them careening inward toward the inner solar system. Perhaps it was simply the natural, chaotic settling of a young solar system, with countless leftover debris taking eons to find their final resting places. Whatever the profound reason, Earth became a colossal target, and for hundreds of millions of years, it endured an incessant, fiery rain of stone and ice. Imagine craters the size of entire continents, seas of lava remelted again and again by successive impacts, and yet, in the fleeting aftermath, pools of water collecting, delicate molecules colliding, chemistry beginning to subtly stir. To call it violent is undeniably true, but to call it futile is to miss the profound paradox at its heart. The bombardment was incarnate paradox. Every strike, a wound, every wound a doorway to something astonishingly new. The sheer scale of it is difficult for our minds to fathom. One asteroid large enough to reshape an entire continent could arrive every few thousand years, with countless smaller ones falling constantly in between. The surface was never truly safe, never truly stable, but each strike also served to violently mix the planet's materials, melt rocks anew, and create environments of extreme heat and pressure where chemistry could run wild and unpredictable. Some impacts vaporized entire nascent oceans of magma, others delivered fresh, pristine ice from beyond the asteroid belt. Some may have temporarily sterilized the surface, others may have created sheltered, transient pockets where delicate molecules survived and combined. Out of this profound chaos, out of this relentless battering, Earth was being stocked and stirred like a colossal cosmic cauldron. If the Hadean was the forge, then the late heavy bombardment was the seasoning, the dramatic sprinkling of spices by a chef who preferred explosions to teaspoons. And here lies the subtle, dark humor. Imagine the cosmos as an impatient cook, shouting across the vast void, "Needs more water, needs more carbon, needs more shock energy," and hurling yet another asteroid to fix the recipe. Earth, battered and bruised, could only reply, with a weary sigh, "I said simmer, not slam." Yet the slams continued, relentless and unforgiving, and with them came both indelible scars and indispensable sustenance. What today we perceive as ancient craters may once have been vast, bubbling mixing bowls, each one a unique place where minerals and water mingled, where intense heat gave fleeting opportunities for chemistry to leap forward in profound ways. The very violence of this era may have been the unexpected key to jump-starting the intricate processes that later evolved into the miracle of life. The moon stands as silent, cratered testimony to this ancient storm. Unlike Earth, it possessed no atmosphere, no vast oceans, no dynamic tectonics to erase its wounds. Its surface is a fossil record of impacts, a desolate graveyard of craters left from the relentless bombardment. Each circular scar on its face is a stark reminder of the cosmic shooting gallery Earth endured as well. But where the moon was simply scarred, Earth profoundly transformed. It absorbed the blows, digested the deliveries, and moved forward, resilient and determined. If the moon is a scarred veteran, Earth is the survivor who turned every wound into a unique strength. The bombardment did not destroy Earth, it armed it, filled it, primed it. One might almost call it a cosmic hazing ritual, brutal but ultimately formative, after which Earth emerged tougher, richer, and ready for the next, equally dramatic act in its unfolding story. There is a deep mystery here too. The oldest surviving minerals on Earth, those tiny enigmatic zircons, suggest that liquid water may have existed surprisingly early, even during or shortly after this brutal bombardment. If true, it means that vast oceans began forming even while the fiery rain of impacts continued, that pockets of precarious stability coexisted with profound chaos. It is a tantalizing image, nascent lakes shimmering in the brief calm between impacts, only to be boiled away by the next colossal strike, then reformed again with the next delivery of icy comets, a relentless cycle of destruction and renewal, repeating countless times until one day the delicate balance tipped irrevocably toward endurance. Perhaps life itself began in those fleeting, sheltered windows, tiny experiments sparked by energy and chemistry, surviving just long enough to be carried forward to calmer, more hospitable times. If so, then the late heavy bombardment was not only Earth's greatest trial, but also its unexpected midwife. It is tempting in the face of such profound paradox to see intention in this cosmic violence, to perceive the bombardment not as random, chaotic chance, but as an integral part of a vast cosmic plan, a violent delivery service, ensuring that Earth had precisely what it needed to become a living world. Was the universe throwing weapons at a nascent planet, or was it handing over vital gifts disguised as devastating blows? Perhaps both. Perhaps the universe, in its strange, inscrutable way, knows no fundamental difference between a hammer and a gift, between war and blessing. It shapes with the very same tools it uses to destroy. Earth itself might have whispered in the deafening chaos, "Hit me harder, I can take it. Each strike makes me stronger," and stronger it undeniably became. The bombardment eventually waned. The relentless supply of stray comets and asteroids thinned, The young solar system settled into a more predictable rhythm, and Earth finally had room to breathe, or at least to recover from its colossal bruising. What was left behind was a scarred but seasoned planet, its surface profoundly altered, its interior enriched, its reservoirs of water expanded, its inventory of organics richly stocked. It was not yet the Earth of vast oceans and towering continents, but it was no longer just the incandescent furnace of the Hadean. It had endured the storm and taken from it the very tools it would need to build oceans, atmospheres, and eventually the fragile, astonishing miracle of life. What once seemed like pure, unadulterated destruction reveals itself in hindsight as a paradoxical, profound act of creation. So the late heavy bombardment remains one of the most astonishing, yet least understood episodes in planetary history, a storm of fire and stone that lasted hundreds of millions of years, reshaping entire worlds, scarring the moon's face for eternity, and profoundly transforming Earth. It is remembered not in human myths, for no humans were there to witness it, but in the indelible craters, the ancient rocks, and the subtle chemistry left behind. To tell its story is to tell of violence that masqueraded as generosity, of impacts that looked like assassins but carried precious water, of blows that seemed cruel but carried the very building blocks of organics. Was it war? Was it gift? Was it accident? Was it plan? Perhaps it was all of these. Perhaps none. But in the echoes of that ancient rain of stone, in the whisper of craters and minerals, one can almost hear the universe chuckle. Sometimes my presence arrive with a bang, and Earth, scarred but undeniably smiling, might reply, I was hit hard, but it was worth it. If you could travel back in time to the earliest chapters of Earth's history and attempt to take a deep breath, that breath, tragically, would be your very last. The air of the primordial planet was not the familiar, life-sustaining cocktail of oxygen and nitrogen that sustains us today. Instead, it was a strange shifting experiment in chemistry, a nascent sky that seemed to change its mind as often as Earth itself reshaped its tumultuous surface. The very first atmosphere, if one can even call such a flimsy veil by that name, was born along with the planet, a thin, transient cloak of gases captured from the swirling solar nebula, hydrogen and helium, the lightest, simplest elements in the entire universe, gathered briefly around the young world, forming an airy, ephemeral shroud. But this cloak was flimsy, fragile, destined to vanish almost as soon as it appeared. Earth's nascent gravity could not hold such light gases against the relentless, stripping force of the solar wind, so hydrogen and helium slipped silently away, streaming off into the vastness of space like balloons escaping a child's startled grip. Earth, shrugging its colossal shoulders, might have sighed, well, that was short-lived, and just like that, the first fleeting atmosphere was gone. What followed was not emptiness, but a new, more profound phase of breath. This one forged not from cosmic leftovers, but from the planet's own restless, fiery insides. Volcanoes, countless and furious, belched gases in colossal incandescent plumes, transforming the thin, ethereal veil into a thick, toxic, enduring shroud. Out came carbon dioxide in staggering abundance, methane in potent, warming bursts, ammonia in acrid, pungent waves, and water vapor in dense, steamy clouds that clung to the scorching surface. The air became less like something you could breathe, and more like the acrid exhaust of a giant cosmic kitchen that had forgotten to open its windows. If modern life had tried to take root then, it would have choked instantly, suffocating in the noxious brew. The sky was thick with potent greenhouse gases, trapping immense heat, swirling with poisons. It was air in name only, more a planetary laboratory experiment than a life support system, and Earth, if it could boast, might have chuckled with a fiery pride. Not breathable, but oh, what a mix. This second volcanic atmosphere was far from static. It pulsed and shifted with every thunderous eruption. Volcanoes belched immense quantities of sulfur, painting the air with acrid, choking fumes. Methane seeped from countless cracks in the nascent crust, a gas that even in tiny amounts can trap heat with ruthless efficiency. Carbon dioxide piled up, heavy and relentless, transforming the sky into a vast, suffocating greenhouse dome. Ammonia wafted through the volatile mix, pungent and sharp. No oxygen yet, not even a trace, just a swirling, dangerous concoction of gases that today would be instantly fatal to every bird, every insect. every human who dared to try and inhale it. The profound irony, of course, is that to Earth itself, this was progress, a vital step in its evolution. The planet had moved from a fleeting, captured cloak of cosmic gases to a homegrown, self-generated brew, one that could linger, one that could profoundly interact, one that would become the dynamic backdrop against which the rest of its magnificent history would unfold. It was a sky still dangerous, still alien, but undeniably more permanent, more substantial. Earth might have muttered proudly, with a puff of volcanic smoke, "This one will If you try to imagine this primordial atmosphere, completely erase the image of gentle blue skies. Picture instead a perpetual haze of deep red and murky brown, thick, churning clouds of gas swirling in constant violent storms, the horizon forever dimmed by volcanic smog and particulate, lightning forked across the sky with wild, untamed abandon, fueled by turbulent gases colliding and separating with immense energy. The air was hot, heavy, and charged with raw, electrical power, a chemical circus in constant dramatic performance. And here is where a touch of gentle humor sneaks in. Imagine Earth standing in a vast cloud of its own fumes, grinning sheepishly and saying, I know, I smell like rotten eggs, but it's all part of the process, you see. Every breath of this ancient world was a potent concoction, toxic yet fertile, dangerous yet bursting with the raw potential for creation. It is strange, perhaps, to think of air as an active character, an actor in the grand drama of planetary creation, but in the Hadean that is precisely what it was. The gases belched from the churning mantle did not simply hover, they interacted, they reacted, they danced with each other in violent, ceaseless storms of chemistry. Methane clashed with carbon dioxide, ammonia dissolved in raindrops that evaporated into steam before ever touching the ground. Sulfur compounds mingled with water vapor to form vast, acidic mists. It was not a calm, harmonious atmosphere. It was a profound planetary cauldron, and like any cauldron, it was both inherently dangerous and incredibly promising. Today, we would flee from such a sky, masks strapped to our faces, alarms blaring a frantic warning. Back then, there was nowhere to run, and Earth would only have laughed a deep, rumbling, planetary laugh. Don't breathe, I'm still cooking. What makes this primordial atmosphere so utterly fascinating is not only what it contained, but what it so crucially lacked. Oxygen, that life-giving, fire-sustaining gas we take so completely for granted, was entirely, profoundly absent. The air was anoxic, utterly hostile to any organism that would later come to depend on oxygen's reactive power. To us, that absence spells inevitable doom. To the intricate chemistry of early Earth, however, it spelled unparalleled opportunity. Without oxygen to interfere, fragile organic molecules could survive longer, combine more freely, and experiment in ways they never could today. It was a laboratory with rules unlike our own. Poison to us, but a vast, open playground to the boundless possibilities of nascent life. The Earth might have whispered slyly, with a knowing, gaseous sigh, "You call this toxic, I call it creative." It is tempting to perceive this stage as ugly, as a fundamental mistake in planetary design, a wrong turn in the cosmic recipe. But that would be akin to judging a complex recipe halfway through the cooking process. A rich stew does not smell sweet when the onions are still raw, and a delicate cake does not look edible when the batter is still bubbling and raw. Earth's primordial atmosphere was not finished food. It was the simmering broth, the baking batter, the smoke-filled, chaotic kitchen that always comes before the grand feast. It looked, smelled, and felt profoundly hostile, but that very hostility was undeniably necessary. Without it, the planet could not have brewed the precise conditions for what would follow. Without vast carbon dioxide, there would have been no greenhouse blanket to keep the world warm enough for water to linger. Without methane and ammonia, there would have been no rich reactive chemistry waiting to be stirred. Without sulfur and steam, no sparks of energy would have crackled through the tumultuous sky. And so the Earth, with volcanic smoke pouring from its pores, could only laugh. A deep, rumbling, knowing laugh. Don't judge me yet. You'll like me when I'm done. The primordial air also carried sound differently. Thick with dense gases, heavier than our present atmosphere, it may have muffled some noises while dramatically amplifying others. The incessant roar of eruptions, the searing hiss of steam, the crack of lightning, they must have echoed strangely, distorted and profound by the dense, swirling shroud. Imagine standing in that terrifying soundscape, not that you'd survive for an instant, hearing thunder that rattled not just your bones but the very ground beneath you, a vibration that resonated through the planet itself. The atmosphere was alive with voices, most of them threatening, a symphony of raw power, and Earth in its own profound way was learning to speak through them, to express its nascent identity. There is also a kind of subtle comedy in how fleeting the first hydrogen-helium atmosphere was, especially when compared to the robust volcanic breath that followed. The first cloak blew away like cheap perfume in the wind, gone in an instant, ethereal and transient. The second, by profound contrast, settled in like a stubborn, indelible smell in a kitchen, clinging to every corner, every nascent rock. Hydrogen and helium were flighty guests, unwilling to linger. Carbon dioxide and methane were the rowdy, boisterous friends who moved in permanently, rearranging the furniture of the sky, leaving indelible stains on the cosmic carpet, and firmly insisting they owned the place. Earth, as the weary, long-suffering host, may have sighed with a profound sense of relief. At least they're reliable. For hundreds of millions of years, this toxic, volcanic atmosphere endured. It trapped immense heat, it churned violent storms, it painted the sky in lurid, dramatic colors. It was a constant, stark reminder that Earth was not yet a hospitable home but still a colossal project under construction, still a chaotic workshop smelling perpetually of sulfur and steam. And yet, if you listen carefully to the unfolding story, you hear the profound rhythm of preparation, the subtle cadence of creation. Each volcanic belch was a distinct note in the planet's symphony, each gas a crucial player in the orchestra, each lightning strike a conductor's fiery baton. The music was loud, discordant, frightening, yes, but it was music nonetheless, a primal hymn of becoming. Out of this profound cacophony, order would someday inevitably emerge. And so if we imagine Earth's primordial atmosphere as a character, it was a trickster, a jester in the colossal court of creation. It was foul, yes, and undeniably deadly, but it was also playfully mischievous, mixing ingredients with reckless abandon, tossing molecules together just to see what happened, what new wonders might emerge. It was a laboratory without safety goggles, a kitchen without recipes, a stage without a script, a grand improvisation. And in that profound chaos, in that dangerous, unpredictable improvisation, lay the subtle, nascent seeds of everything to come. Earth, breathing its foul, potent gases, might have winked at the cosmos and said, with a knowing, gaseous grin, "Don't inhale, but do pay attention." By the time the primordial atmosphere settled into something more stable, more enduring, Earth had been transformed yet again. It was no longer wrapped in fleeting hydrogen and helium, no longer naked and gasless, but cloaked in its own profound volcanic breath. It was thicker, more enduring, more stable, if not yet friendly. It was air you could not breathe, air that would kill you instantly, air that smelled perpetually of sulfur and acid, but it was air that stayed, and in staying, it gave Earth a new kind of identity, a voice. From that point forward, Earth was not just a rock with fire inside it. It was a rock with breath, a world that exhaled, a planet that had learned how to speak in gas, in plumes, in storm. That speech was foul, yes, but it was the profound beginning of dialogue, the very first whispers of a story that had only just begun to unfold. And if you stood on the edge of that ancient world, holding your breath as long as you could, you might have heard it whisper back to you, "I'm not ready for you yet. Don't breathe me, don't live in me, but watch closely, because in this toxic breath, I am learning how to become a world." Among the grand, shimmering questions of Earth's earliest history, few resonate quite like this one. Where, precisely, did the water come from? Today, our world is famously wrapped in a breathtaking expanse of blue, two-thirds of its magnificent surface hidden under oceans so vast they seem eternal, an ancient, liquid memory. But water, in the grand cosmic story, is a surprisingly late comer, a liquid stranger that had to arrive somehow, miraculously, on a planet born in the incandescent heart of fire. Earth began as a furnace, its surface too scorching to allow any droplet to linger, its skies too poisonous to welcome gentle rain. Yet, astonishingly, within a few 100 million years of its cataclysmic birth, perhaps as early as 4.4 billion years ago, evidence subtly tells us that liquid water already pooled on its tumultuous surface. That is astonishingly early, almost indecently fast, as if the universe, impatient for the next act, poured the oceans onto the stage before the fiery scenery had even finished cooling. Earth, if it could look back on its youth with a wry smile, might shrug and laugh. I was thirsty, and the cosmos quite simply obliged. The precise sources of that water remain part of a profound mystery, a cosmic puzzle with several compelling answers that may, in their entirety, all be true at once. Some scientists thoughtfully argue that much of Earth's precious water came from beyond, carried in by icy comets or water-rich asteroids that crashed onto the surface during the relentless great bombardments. Imagine them as colossal, cosmic delivery trucks, tumbling through the darkness of space with their cargo of pristine ice, arriving violently but carrying precisely what was needed to quench a nascent world's thirst. Each thunderous impact not only scarred the planet but melted, boiled, and scattered countless water molecules, which then, as the surface slowly cooled, condensed and collected, filling the burgeoning basins. Others suggest, with equal conviction, that Earth carried water from the very beginning, locked deep within its primordial rocks, bound within the intricate minerals formed in the swirling, dusty disk of the solar nebula. As the planet heated and melted, as its interior convulsed, those minerals released their hidden, ancient stores, exhaling vapor that eventually cooled into liquid. In this view, water was not an exotic import, but a native inheritance, a fundamental part of Earth's very recipe from the start. Perhaps, as often happens in the most compelling stories, the truth lies in a harmonious blend. Precious gifts from the skies mingled with subtle whispers from the rocks, cosmic and local together, a profound duet of sources that filled the thirsty basins of the young world. It is tempting to picture this momentous transformation romantically, and indeed it richly deserves a touch of cosmic romance. Imagine a planet that has raged with incandescent fire for eons, its skin cracked and molten, its breath foul with toxic gas. Slowly, painstakingly, it cools, its surface hardens, its fiery fever gently breaks. Steam condenses in the thick, primordial air, droplets fall, sizzling at first upon the hot rock, then pooling, joining, spreading across the nascent crust. Rain falls not for mere hours, not for days, but for thousands of years, endless torrents filling every hollow, smoothing every jagged scar left by the bombardments. The sound of that incessant rain, if anyone had been there to hear it, must have been deafening. A planet-long symphony of water striking rock, a primal rhythm. From space, Earth would have begun to shimmer, vast patches of silver and blue spreading across the once fiery surface. The first oceans were not gentle, tranquil seas, but steaming cauldrons, boiling under the planet's retained heat. Yet they were oceans nonetheless, liquid water on solid rock, a profound miracle in any universe. Earth, catching its reflection for the very first time, might have whispered in pure delight, "At last I can drink." But before the oceans fully gathered, there were questions, scientific queries to be answered. Comets, those enigmatic, icy wanderers, were long the favored candidates for delivering Earth's water. They are, after all, famously dirty snowballs, rich in frozen water, and it is easy to imagine their icy cargo splashing down on Earth in the chaos of the late heavy bombardment. Each impact, though catastrophic, carried the potential to add to the global reservoir. Yet, when scientists meticulously studied the isotopes of hydrogen in cometary water, they found that many comets carry a different isotopic fingerprint than Earth's oceans. The ratio of deuterium to hydrogen did not quite match, subtly suggesting that while comets may have contributed, they were not the only or even the primary source. Asteroids, particularly carbonaceous chondrites, began to seem like stronger, more compelling suspects. These rocky bodies, laced with hydrated minerals, could carry water locked within their crystalline structures, hidden from plain sight. Their isotopic signatures match more closely with Earth's water, hinting that perhaps the majority of our oceans came not from distant icy comets, but from stony messengers that looked dry on the outside, yet carried vast, hidden reservoirs within. Earth might have grinned at the thought, you can't judge a rock by its cover. And then there is the profound possibility of endogenous water. Water that was always here, woven into Earth's very building blocks from its inception. Silicate minerals formed in the early solar system often incorporated water molecules within their intricate lattices. When Earth melted and differentiated, when its interior convulsed and released vast quantities of gases, water vapor was among the most abundant exhalations. Some of that vapor, of course, escaped into space, but a significant portion condensed, fell as rain, and stayed. If this is true, then water is not merely an addition from beyond, but a fundamental part of Earth's inheritance, written into its very birth certificate. It would mean that the oceans were, in a profound sense, inevitable, that the planet was destined from the start to be wet, a blue jewel. Perhaps, as is often the case in the grand tapestry of the cosmos, both stories are true: water delivered from afar, water released from within. The universe, in its boundless wisdom, does not mind redundancy. If the ultimate goal was to create a blue planet, it seems the universe wanted to be very, very sure the recipe worked. What makes this swift appearance of water so utterly extraordinary is the sheer speed with which it happened. Evidence from those ancient zircons suggests that liquid water already existed on Earth by 4.4 billion years ago, a mere cosmic blink after its tumultuous formation. That means the oceans were born while the scars of the bombardments were still fresh, while the crust was still fragile, while the air was still thick with poisonous gases, and yet, in that incredibly hostile setting, water pooled and lingered, tenacious and persistent. If you could have stood there, though, as we've established, you could not. You would have seen vast lakes of steaming water, spreading, deepening, merging into nascent seas. The planet that had once glowed incandescent red with molten fire now shimmered with reflective blue, a transformation as dramatic as any in cosmic history. Earth had changed costumes, shedding its fiery mask for a watery cloak. It must have been a shocking sight, even to the silent stars watching from afar. Earth might have smirked with a touch of newfound pride. Told you I'd clean up nicely. The oceans of that ancient time were not like the oceans we know today. They were hotter, more acidic, heavy with dissolved minerals, leached from the fresh, still-forming crust. Their colors may have been stranger too, perhaps tinted green or brown by chemical soups simmering within their depths. Waves crashed not on soft, sandy beaches, but against jagged, black volcanic rock, spraying superheated steam into the thick primordial air. Yet, for all their strangeness, they were oceans vast and persistent, covering much of the surface. They profoundly altered the planet's climate, its chemistry, its very personality. A world with water is a world with reflection, with cycles, with rhythm. The oceans became Earth's mirrors and metronomes, shaping its nascent days and nights, its heat and cold. From the very moment they arrived, Earth was no longer merely a rock. It was a water world, a blue heart, beating in the cosmos. And here is where humor gently sneaks in again, because the story of water is both profoundly violent and exquisitely tender. It arrived in crashing impacts, shattering blows, colossal collisions that reshaped the very crust of the planet. And yet, out of that raw violence came the gentlest of substances, droplets that soothe, waves that lap, vast seas that cradle. It is like a cosmic paradox, the universe delivering tenderness in the most unexpected form. Hammer, Earth, drenched and steaming, might have coughed with a wry smile and said, "That was rough, but undeniably refreshing." The irony is delicious. A planet beaten into beauty, battered into liquidity, pummeled into poetry. The oceans did more than merely shimmer. They altered geology itself, profoundly and irrevocably. Water seeps, dissolves, reacts. It cools hot rock. It carries minerals in solution. It creates intricate cycles of erosion and deposition. Once water was present, Earth's surface could no longer remain static. The hydrological cycle was born, crude at first but unstoppable. Evaporation, condensation, precipitation, runoff. The planet began to breathe differently, to circulate differently, to dream differently. Oceans were not merely decoration, they were powerful engines. They redistributed heat, they sculpted nascent landscapes, They set the stage for chemistry far richer and more complex than the dry crust alone could ever offer. They transformed Earth into a vast laboratory not just of fire but of exquisite, life-giving liquid. What strikes the imagination most profoundly is the persistent idea that the universe seemed utterly determined to provide water, no matter the method, no matter the cost. Whether in cometary ice, asteroid minerals, or endogenous vapor, it ensured Earth would not remain dry. It is as if water was non-negotiable, as if the cosmos had whispered, with a profound sense of purpose, "A planet without oceans is just a rock. A planet with oceans can be a cradle." Was this pure chance? Was it profound inevitability? Was it deliberate design? The question lingers like morning mist, elusive and tantalizing. Science offers probabilities and meticulously gathered evidence. Philosophy offers boundless wonder. Humor, perhaps, offers the simplest answer. Maybe the universe just loves a good cup of tea, and Earth was its favorite mug, meticulously prepared. By the time Earth's oceans had settled into their vast primordial basins, the planet was transformed beyond recognition. No longer a fiery incandescent orb, it was a shimmering sphere, half cloud, half water, already bearing the nascent look we know today. The oceans stretched vast and deep, their surfaces reflecting the light of a young sun, their mysterious depths hiding chemistry that would soon stir toward the miracle of life. They were not yet gentle seas filled with whales and coral. They were hot, acidic, and profoundly strange, but they were oceans, and their presence meant everything. From that point forward, Earth's destiny was no longer only about rock and fire. It was about water, about cycles, and about the boundless possibility of life. The planet that had once burned with unquenchable fire now whispered with the soft, flowing sound of water. And if you lean close to that whisper, in the quiet of your mind, you can almost hear it say, "I was thirsty," and the universe answered. If the oceans gave Earth its shimmering, reflective surface, it was the volcanoes that quite literally gave Earth its bones, its very structure. Long before the continents grew firm and the air grew gentle, the young planet throbbed with an internal, ceaseless fire. It pulsed through countless cracks in its nascent skin, burst through vents in magnificent fountains of lava, and roared upward in colossal plumes of ash and steam. Volcanoes were not rare, isolated features in this ancient time. They were everywhere, as common as atmospheric storms, as constant as the beat of a primal drum. Their furious eruptions shaped the nascent crust, belched vital gases into the sky, and quite literally breathed the planet's secondary atmosphere into being. To imagine early Earth without volcanoes is like imagining a blacksmith's forge without fire. The magma chambers were the planet's turbulent heart, the eruptions were its ceaseless heartbeat, and every explosion was a hammer strike in the cosmic blacksmith workshop of creation. Earth itself might have muttered, between eruptions, with a grim pride, "I was forged in fire, don't come too close." Picture the scene, a surface still profoundly young, fragile, constantly cracking under the immense strain of internal heat. Magma pushed upward relentlessly, breaking through in fiery fountains, spilling across the landscape in vast incandescent rivers of liquid stone. These fierce flows cooled and hardened into the very first crust, only to be broken, melted, and replaced again and again by subsequent eruptions. The crust of the early planet was not the stable bedrock we know today, but a restless, ever-changing quilt, meticulously stitched and unstitched by fire. Volcanoes poured out basalt, creating vast, dark plains that stretched for miles. Each eruption built new land, fleeting but essential. Without volcanoes, there would have been no crust, no foothold for water, no platform for the intricate chemistry of life to begin. Fire, in its profound chaos, was the planet's ultimate architect. Volcanoes also gave Earth its second, enduring breath. The first atmosphere, a flimsy, ephemeral cloak of hydrogen and helium, had long since fled into the vastness of space. The second atmosphere was entirely volcanic in origin, forcefully exhaled by fire. Carbon dioxide, methane, ammonia, and water vapor surged upward in colossal, continuous plumes, filling the sky with a thick, toxic brew. With every eruption, the planet breathed deeper, exhaling its very insides into the heavens. It was not an air one could breathe, not yet, but it was an air that stayed, tenacious and persistent. Volcanoes were not only sculptors of rock, but authors of sky, writing the very script of climate in plumes of smoke and ash. Earth, with a mischievous, fiery grin, might have said, "I'm a smoker, and my cigarettes are continents." The sheer drama of those primordial eruptions defies easy description, transcends our modern understanding of geological events. Imagine fountains of lava shooting hundreds of meters into the air, glowing rivers moving faster than a galloping horse, vast sheets of molten rock stretching across the horizon, consuming everything in their path. Ash clouds towered to unimaginable heights, turning day into an ominous, perpetual twilight. While firestorms raged below, entire regions remade themselves in a matter of hours, their landscapes buried under flows, so hot they glowed for months. The sound alone would have been terrifying, a planet coughing, growling, screaming in thunderous eruptions that echoed across a world with no forests to dampen the roar, no gentle valleys to absorb the sound. The ground itself was profoundly unstable, trembling constantly, splitting, reforming. Earth was a drummer pounding its colossal kit without pause, a pyromaniac experimenting endlessly with its own fiery essence. And yet, through this profound chaos, something truly remarkable was happening. The very foundation for future stability was being laid, molecule by molecule, rock by rock. As the lava cooled, it solidified into crust. Not continents as we know them, not yet, but islands of rock that thickened and persisted longer than before. These proto-continents were fragile, constantly recycled by new eruptions, but each generation of crust grew tougher, each fiery cycle leaving behind slightly more stability, more permanence. It was an arms race between internal heat and external cooling, between destruction and creation. Over time, the crust thickened enough to resist immediate recycling. The first continental seeds were born out of volcanic rock, resilient and tenacious. Without them, there would have been no land to speak of, no basins for water to fill, no platforms for life to cling to. Volcanoes were both destroyers and midwives, burning and birthing in equal measure, a paradoxical force of nature. And then there is the subtle humor of it all. For as terrifying as these primordial volcanoes were, they were also astonishingly productive, a relentless fount of new material. Each eruption carried within it the rich chemistry of the mantle, silicates, metals, gases, and countless trace compounds that would later prove vital to the emergence of life. It is as if the volcanoes were chefs with notoriously bad manners, throwing ingredients onto the cosmic counter with violent flair. Here, have some iron. Here, a little phosphorus. Oops, spilled a whole mountain of basalt. The kitchen was undeniably a mess, but the pantry was rapidly filling, becoming richly stocked. Earth was stocking its shelves not neatly, not politely, but extravagantly, generously. The magma was messy, but it was profoundly generous, a chaotic gift giver. Volcanoes also stitched together land and water in their own fiery, unexpected way. As water condensed on the surface, it encountered the hot, new rock, steaming and reacting, leaching essential minerals into solution. This intricate chemical interplay created rich, primordial soups of elements that would later become the vibrant playground of nascent life. The volcanic crust was porous, fractured, and highly reactive, offering endless surfaces for delicate molecules to meet and mingle. Even the heat itself, once only destructive, became an integral part of the recipe. Hydrothermal systems bubbled at the margins of lava flows, places where hot rock met cooling water, generating gradients of temperature and chemistry that would prove fertile ground for complexity. The forge of volcanoes was not only shaping continents but experimenting with chemistry at scales both grand and subtly microscopic. If you picture the Earth as a living body, volcanoes were its lungs and its sweat glands, ceaselessly exhaling gases, sweating out molten rock, venting the immense pressure of its restless core. Without them, the planet might have suffocated under its own internal heat, unable to release its profound energy. With them, the energy was released, the surface reshaped, the atmosphere enriched. Every eruption was an exorcism of internal pressure, every plume a sigh of relief, every lava flow a profound release. And Earth, weary but undeniably proud, might have said, through its fiery breath, "You think I'm destructive. I think I'm alive." The secondary atmosphere that emerged from this constant volcanic breath was not kind to us, not breathable, but it was absolutely crucial. It thickened, stabilized, and began to regulate temperature, creating a rudimentary climate. It created cycles of condensation and evaporation, violent storms that lashed the young surface. It was dangerous, yes, but it was also durable, tenacious. Unlike the fleeting hydrogen and helium, this air would linger, persist, and in lingering, it set the stage for vast oceans, complex weather patterns, and eventually the miracle of biology. Volcanoes, with their smoky, fiery exhalations, had given the world not only rock but breath. Poisonous breath? Yes, but breath, all the same. Earth could finally claim, with a profound puff of methane and carbon dioxide, "Now I can breathe on my own." Over millions of years, this fiery cycle continued, relentlessly, magma rising, lava spilling, crust thickening, gases swirling. It was exhausting, relentless, chaotic, but it was also undeniable progress. Slowly, painstakingly, the planet moved from a molten ball to a layered world, from bare incandescent rock to islands of nascent crust, from profound silence to roaring storms. Volcanoes, in their fury, had written the opening chapters of geology, the very grammar of the planet. They had shaped the crust, breathed the air, seeded the chemistry, and carved the first rough outlines of continents. They were terrifying, yes, but they were utterly indispensable. Earth would not be Earth without them, not the Earth we know. And so when we think of volcanoes today, spectacular but relatively rare, we must remember that once they were the norm, the very heartbeat, the ceaseless forge, the Hadean world was defined by their fire, sculpted by their lava, enriched by their gases. They were the architects of land, the authors of sky, the tireless chefs of chemistry. They were, in every profound sense, the blacksmiths of creation. And if Earth could look back on those tumultuous days, it might grin through its scars and say, "I was a volcano once. Fire made me, fire prepared me. Fire made me ready for life." If Earth could keep a diary, most of its earliest pages would have been burned, torn, and utterly erased. The Hadean was a time of fire and chaos so profound that any crust that tried to form was constantly melted, shattered, and recycled back into the planet's depth. Rocks from that ancient age are almost entirely gone, destroyed in the planet's restless, internal recycling machine, and yet, against all odds, fragments of that deep memory remain, tiny, unassuming crystals that have miraculously outlived oceans, mountains, continents, and cataclysms beyond imagining. They are called zircon. To the untrained eye, they are nothing special, just small, often microscopic grains, far from glamorous gemstones. But to geologists, to those who understand their profound secret, they are priceless treasures, time capsules, cosmic USB drives that hold the encrypted code of Earth's earliest days. And like any USB, they might look tiny and ordinary, but within them are stories more valuable than any jewel. Earth might whisper, with a knowing, ancient smile, "Read me carefully. I hid my secrets in zircon." The oldest known zircons, discovered in the remote Jack Hills of Western Australia, date back an astonishing 4.4 billion years. That date is staggering, almost incomprehensible. It means these resilient crystals formed not long after Earth itself was born, while the planet was still fresh from the cosmic forge, still battered by relentless impacts, still a place of incandescent fire and raging storms. How could anything so fragile in appearance possibly survive from then until now? The answer lies in the profound durability of zircon. Built from zirconium, silicon, and oxygen, arranged in an incredibly stable crystalline lattice, these grains are nearly indestructible. They resist immense heat, crushing pressure, and relentless erosion. They can survive the recycling of crust that utterly destroys other less resilient minerals. They are, quite literally, immortal compared to most rock. If Earth's geology is a vast library where most books have been consumed by fire, zircon is the fireproof notebook that somehow slipped through the flames, preserving its precious content. But what makes zircon more than just a survivor is what it so patiently contains. Trapped within its intricate crystal lattice are subtle chemical signatures, precise ratios of isotopes, tiny, almost invisible inclusions that reveal the exact conditions under which it. In the case of those ancient Jack Hill zircons, the isotopes whisper something truly remarkable across billions of years. They suggest that by 4.4 billion years ago, Earth already possessed a solid, if nascent, crust and even liquid water at its tumultuous surface. Think about that for a moment. Only 100 million years or so after Earth's violent, fiery birth, after the endless magma seas and the relentless bombardments, there were already places cool enough for rocks to crystallize and for water to pool. That is astonishingly early, almost as if the planet was in a profound hurry to write its story. And the only reason we know this is because zircon kept the meticulous receipt. The crystals recorded the isotopic ratios of oxygen in their structure, and those ratios tell us they intimately interacted with liquid water. In other words, zircon remembers rain, ancient, primordial rain. The idea is almost poetic, isn't it? A tiny grain of crystal, no bigger than a speck of sand, holds the profound memory of ancient rain falling on hot rocks billions of years ago. It is as if the Earth, in its profound wisdom, entrusted its earliest, most precious secrets to the smallest possible messenger, confident that the humble would endure, while the mighty were destined to be destroyed. Mountains crumble, vast oceans evaporate, continents drift across the globe, but zircon remains, whispering its ancient tale across deep time. I was here, it says, in a voice of profound stillness. I remember when Earth first cooled. I remember when the first fragile crust hardened. I remember when water first kissed the hot, nascent rocks. To hold a zircon in your hand is to physically touch a witness that has seen the planet's very first tentative step. If you are sentimental, it feels like shaking hands with prehistory itself, a profound connection across unimaginable gulfs of time. Scientists use uranium-lead dating to meticulously unlock zircon's ancient memory. Uranium atoms trapped within the crystal at its very birth slowly decay into lead at a predictable constant rate. By precisely measuring the ratio of uranium to lead, geologists can calculate the crystal's age with exquisite precision. It is like reading a clock that ticks so incredibly slowly it measures not seconds or minutes, but billions of years. When those clocks pointed back to 4.4 billion years, jaws dropped in scientific astonishment. It was older than any rock yet found, older than most imagined Earth could even support stable crust. And yet there it was, a tiny crystal in Western Australia, calmly declaring, "Yes, I was born when the world was still hellfire." It is hard not to laugh at the profound irony. The most durable testimony of Earth's earliest history is not a towering mountain, but a humble speck of sand. Earth, with a sly, knowing grin, might say, "Never underestimate the little ones." Zircons also tell us about the early crust itself, a story of nascent complexity. Their chemistry subtly suggests they formed not from raw basaltic magma, but from crust that had already differentiated, crust more akin to granite, more evolved. That implies that Earth's surface was already recycling, melting and reforming, even then creating pockets of stability and complexity amidst the chaos. It was not a static molten ball forever. It was experimenting, layering, creating niches where water could linger, where new chemistries could begin. Zircon tells us that the early crust was not just fleeting lava plains, but sometimes thicker, cooler, more continental in nature. That is a profound revelation, because it paints a picture of Earth as restless but not hopeless, chaotic but profoundly capable of calm. The planet was not only fire, it was already flirting with stability, with a future of solid ground. Zircon in its quiet ancient voice confirms this. The world was not only chaos. There were moments of balance, moments of peace. There is a subtle humor in the idea that zircons are like tiny USB drives buried patiently in the ancient dirt. They are small, unassuming, and easy to lose, yet packed with invaluable data. Imagine Earth dragging its colossal pockets and saying, with a knowing wink, "Here, I saved the files, just don't drop them," and humanity, billions of years later, finds them, carefully plugs them into the sophisticated instruments of isotope geochemistry, astonished that the files still open, still reveal their secrets. In a way, zircons are far superior to modern USBs, because USBs corrupt after a decade or two, while zircons last almost forever, enduring beyond comprehension. If we ever wanted to back up our entire civilization for the next 4 billion years, perhaps we should take notes in zircon. The crystal, if it could, would chuckle, "Good luck fitting your movies in me." But zircons also raise tantalizing, profound mysteries. If they can survive for billions of years, what else might they be subtly hiding within their intricate structures? Could they hold chemical whispers we have not yet decoded, subtle signatures of processes we have overlooked, or simply cannot yet comprehend? Some suggest zircons may even preserve traces of plate tectonics in embryo, hints that Earth's crust was already shifting and recycling earlier than we thought possible. Others speculate about tiny inclusions, minute trapped minerals, that could reveal still more about the precise chemistry of the earliest surface. Each zircon is a capsule of unknowns, as much as knowns, a silent messenger whose profound story is still slowly unfolding. It is humbling to think that the planet's greatest secrets might rest not in vast landscapes or towering mountains, but in grains smaller than a fingernail clipping. And so, in the seemingly ordinary Jack Hills of Western Australia, in outcrops that to most appear unremarkable, scientists diligently dig for these tiny ancient storytellers. They polish them, scan them, read their isotopic tales with meticulous care. Each crystal is a voice from a time no other rock remembers, a voice from before continents, before stable oceans, before air you could breathe. They are fragile in size, but immortal in their endurance. And when you hold one, you are holding not just a mineral, but memory made solid, memory etched in atoms. Earth chose zircon as its archivist, its historian, its tiny, enduring librarian. And if you listen closely, in the profound silence, it might say, "I am older than your mountains, older than your oceans, older than your dreams. I was here when Earth was still chaos, and I remember." In the grand sweeping narrative of planetary history, zircon is both profoundly comic and deeply profound. Comic, because the oldest, most reliable storyteller is a humble grain you could easily lose between your fingers. Profound, because without it, we would know so little of Earth's earliest, most tumultuous days. It is a powerful reminder that memory does not always rest in the mighty, that sometimes the universe entrusts its greatest, most profound secrets to the smallest, most unassuming vessels. Zircon is Earth's cosmic USB drive, its indestructible flash memory, its diary meticulously etched in atoms. And unlike most diaries, this one does not exaggerate, does not embellish. It simply records. It simply remembers. And so, as we marvel at these tiny, resilient gems, we should remember the profound truths they tell us. That Earth cooled sooner than we thought, that water was here earlier than we dared to dream, that stability existed even amidst the most profound, primordial chaos. Zircon is the quiet witness, the stubborn survivor, the meticulous archivist of the Hadean. It does not speak loudly, but when we finally learn to listen, its voice is clear, resonant, and undeniable. Read me carefully, I remember more than you think. Somewhere between incandescent fire and life-giving water, between profound chaos and nascent calm, between the thunderous roar of volcanoes and the hushed whisper of new oceans, something truly remarkable, almost miraculous happened. It was quiet, almost imperceptible, a faint whisper in the great, raging storm of creation. Around 3.8 billion years ago, when Earth was still profoundly young, still scarred by impacts, still noisy with endless bombardments and boiling seas, the very first tentative signs of life appeared, tiny, invisible, exquisitely fragile, yet utterly unstoppable. The oldest traces are not grand fossils or towering creatures, but subtle chemical whispers, locked in ancient rocks, hints of microbial activity, faint signals that some rudimentary form of metabolism had taken hold. That momentous moment, when intricate chemistry tipped into complex biology, is one of the greatest mysteries of all time, a profound enigma. Did life arise here, spontaneously, in the cauldrons and pools of a restless, dynamic planet? Or was it delivered, already packaged, by comets and asteroids carrying organic cargo from the distant cosmos? Was Earth a cradle, or merely a welcoming host? And lurking subtly behind that profound question, the one that nags like a conspiracy whispered in the dark, was this all a grand accident, a cosmic roll of the dice, or was it in some deeper sense, meticulously arranged, intended? The idea of life forming spontaneously on Earth, through natural processes, has long been a cornerstone of scientific inquiry. Imagine shallow pools, gently warmed by volcanic heat, richly infused with dissolved minerals and organics, delivered by impacts or brewed in the thick primordial atmosphere. These warm little ponds, as Charles Darwin once famously speculated, could have been vast, natural laboratories where countless molecules bumped into each other endlessly, forming chains, rings, and structures of increasing complexity. Energy came from incessant lightning, potent ultraviolet sunlight, and searing geothermal heat. The indispensable ingredients, carbon, hydrogen, nitrogen, oxygen, phosphorus, sulfur, were all present, meticulously stirred by storms, concentrated by evaporation, sparked into novelty by sudden jolts of energy. Over countless cycles, the profoundly improbable became in time inevitable. Molecules that could replicate themselves arose, crude at first but tenacious and persistent. And once replication began, natural selection had a vital foothold. From simple molecules to rudimentary protocells to complex microbes, the leap seems vast, almost insurmountable. But given billions of experiments running in parallel across a turbulent, dynamic planet, it may have been in a profound sense unavoidable. Earth, if it could smile, might have said, with a knowing primordial chuckle, I had a recipe. I let it simmer, and look what miraculously bubbled up. But then there is the other profound possibility, the one that tingles with an undeniable sense of cosmic mystery, panspermia. The audacious idea that life, or at least its fundamental building blocks, came from somewhere else entirely, hitching a ride on comets, asteroids, or even interstellar dust. We now know that space is not sterile. It is teeming with chemical potential. Complex organic molecules have been detected in vast interstellar clouds, on distant comets, and in meteorites that fall to Earth even today. Amino acids, the basic building blocks of proteins, have been discovered in meteorites, silent messengers from beyond. Some experiments even suggest that microbes, meticulously shielded within resilient rocks, could potentially survive the harsh journey through space, enduring radiation and extreme cold, waking again upon arrival on a new, hospitable world. If that is true, then Earth's first life may not have been invented here at all, but profoundly imported. In this intriguing view, our planet was less a cradle and more a colossal receiver, a pristine petri dish meticulously seeded by the cosmos itself. Perhaps the seeds were sown deliberately, with purpose. Perhaps it was simply the pervasive habit of the universe to scatter life wherever it could. Either way, it raises the eerie, profound possibility that life on Earth is not unique, but part of a vast cosmic diaspora, a chain of seeds cast from one habitable world to another. Earth, glancing upward at the starry sky, might have whispered, with a subtle sense of gratitude, "Thanks for the delivery." The available evidence does not, regrettably, give us absolute certainty. The oldest rocks that survive are fragmentary, scarred by eons of geological upheaval, and the traces of early microbes, exquisitely subtle, isotopic ratios of carbon that suggest biological fractionation, layered textures that strongly resemble ancient microbial mats, chemical anomalies that hint at rudimentary metabolism. Nothing is definitively conclusive. Everything is hotly contested, debated. And yet, taken together, they subtly tell us that by 3.8 billion years ago, life was here. Not complex, not multicellular, but simple microbes, already making a living, already leaving a faint, indelible chemical fingerprint in the ancient stone. If they were born on Earth, they must have arisen with astonishing speed, almost as soon as conditions permitted, a rapid burst of biological innovation. If they came from space, they must have arrived just as swiftly, ready to take advantage of a newly habitable niche. Either way, the sheer speed is unsettling, provoking deep thought. Was life so profoundly inevitable, written into the very laws of chemistry? Or was Earth's surprisingly early appearance of life the result of a cosmic courier service running ahead of schedule, delivering its precious cargo with uncanny precision? Science shrugs, offering probabilities. Conspiracy theorists grin, seeing pattern. Earth, with a mischievous ancient glint, says, "Surprise!" There is a dark yet profound humor in imagining this. Picture a comet barreling toward Earth, its icy core filled with complex organic molecules, crashing spectacularly, and out of the smoke and chaos emerges not just destruction, but the very seeds of biology. Or picture a shallow pond, bubbling with volcanic heat, lightning striking, molecules organizing themselves with uncanny precision, and the first microbe rising from the primordial soup like a magician's trick. Both images are absurd and magnificent simultaneously. Both make you laugh and shiver at the same time, caught between wonder and disbelief. Either way, life began in circumstances so profoundly unlikely that to call it a mere accident feels utterly insufficient, almost disrespectful. Some whisper it must have been planned, nudged, intended, perhaps not by gods with beards, but by the universe itself, which seems to possess a peculiar habit of transforming chaos into breathtaking complexity. Perhaps physics and chemistry are the ultimate conspirators, quietly rigging the game, setting the stage. Earth might chuckle, with a deep knowing rumble. You call it improbable, I call it inevitable. Once life began, however small and invisible, it left an indelible mark. Tiny though it was, microbial life profoundly altered the chemistry of its surroundings, consuming, excreting, leaving isotopic traces that billions of years later would still betray its ancient presence. These microbes were the intrepid pioneers, the silent colonizers of a world that had no idea it was alive, a world waiting to be transformed. They left no grand fossils visible to the naked eye, but they changed the planet in ways subtle and profoundly significant. To think that something so infinitesimally small could begin to shift the destiny of an entire planet is humbling, awe-inspiring. To imagine that it may have been delivered by a distant asteroid or brewed in a simple puddle of warm water is both comic and profoundly awe-inspiring. If you are inclined to conspiracy, you might say it looks suspiciously like someone wanted it to happen. Earth, rolling its colossal eyes, might mutter, with a touch of exasperation, "Don't overthink it. I just got lucky." And yet, the timing continues to provoke profound wonder. Life appearing around 3.8 billion years ago means that the planet had hardly cooled, had barely stabilized, before biology arrived. It did not wait billions of years for conditions to become perfect. It sprang up almost immediately. That is either compelling evidence that life emerges easily, almost universally, wherever conditions are right, or compelling evidence that it was introduced, seeded, inserted like software on a blank hard drive. Was Earth subtly? Did someone or something out there upload life into its nascent system? The thought is absurd, yes, and yet it lingers, tenacious and persistent, because the alternative, that life arises spontaneously almost every time it can, leads to an equally startling conclusion, that the universe is teeming with life, vibrant and abundant. Both possibilities make you pause, make you reconsider. Both are profound conspiracies of wonder, stretching the limits of our imagination. The microbes of 3.8 billion years ago were not glamorous, not magnificent in the way we understand life today. They were tiny, invisible, fragile, but they were also incredibly resilient, remarkably adaptable, profoundly persistent. They endured immense heat, intense radiation, devastating bombardments, and toxic poison. They clung to existence with astonishing tenacity, a primal will to survive. They were the very first to say, in their silent microbial way, "We are here," and once here, they never truly left. Everything since the towering forests, the majestic dinosaurs, the vast whales, the conscious humans, are elaborate, intricate elaborations on that first faint whisper. But the whisper itself remains exquisitely mysterious. Was it whispered by Earth alone or echoed from the distant silent stars? In the end, We may never definitively know the precise origins. The rocks are too old, too weathered, the evidence too faint, the possibilities too many, too varied. But perhaps the mystery itself is part of the profound point. Life's origin remains beautifully wrapped in ambiguity, delicately balanced between the rigorous pursuit of science and the boundless realm of wonder, between the predictable laws of chemistry and the tantalizing whispers of conspiracy. To think about it is to feel the gentle tug of two voices. The scientist who says, with conviction, it was chemistry, natural and inevitable, and the dreamer who says, with a soaring heart, it was seeded, planted, intended. Perhaps both are right. Perhaps life is inherently natural to the universe, inevitable wherever conditions allow, but also spread from world to world, a cosmic gardener scattering seeds across the vastness. Either way, the undeniable fact remains. By 3.8 billion years ago, Earth was alive. And so we imagine Earth fresh from its profound chaos, scarred and steaming, suddenly home to countless microbes dancing invisibly in puddles, in hydrothermal vents, in cracks in the nascent crust. Earth itself might laugh at the sheer absurdity. From magma to microbes in no time at all. What a magnificent trick! And the universe, inscrutable as ever, might only wink back, as if to say, you weren't supposed to figure it out so easily, were you? If climate today feels unpredictable, a restless dance of storms and droughts and shifting seasons, then imagine the climate of the Hadean Eon. It was not a gentle rhythm of predictable summers and winters, but a colossal roller coaster with no brakes, hurtling between extremes of blistering, incandescent heat and profound icy cold. The young Earth had no balance, no moderation, no polite temperate zones. It was a world trying desperately to decide who it was, vacillating wildly between furnace and freezer, as if the planet were testing costumes before finally choosing its outfit for the rest of history. And the primary actors behind this dramatic, chaotic performance, the restless volcanoes and the crashing asteroids, were the cosmic DJs of climate, scratching the record back and forth, blasting fire one moment and profound silence the next. Earth, dizzy from the relentless ride, might have groaned, adapt or vanish, and then with a colossal shrug, cranked the temperature dial once again. In its earliest, most tumultuous stages, Earth was unbearably hot. Vast magma seas boiled across the entire surface. Volcanoes ceaselessly exhaled superheated steam and potent greenhouse gases, and the very air itself glowed with residual heat. Temperatures soared far beyond anything familiar today, hot enough to melt resilient metals, hot enough that even solid rocks softened and flowed like thick incandescent syrup. The greenhouse effect from vast quantities of carbon dioxide and methane, belched in massive amounts from the planet's turbulent interior, wrapped Earth in a suffocating, fiery blanket. Imagine walking into a sauna filled with searing acid fumes, then turning the dial until the stones glowed incandescent red. That was the Hadean climate at its fiery, terrifying peak. Nothing could breathe it, nothing could live in it, but it was exactly the stage setting the planet so desperately needed. The climate was not a mistake. It was an integral part of the forging, the tempering. Earth, puffing smoke like a magnificent ancient dragon, might have boasted, "I was born in fire, I'll sweat it out." And yet, the pendulum could swing, wildly, dramatically, the other way. There are subtle hints, delicate and hotly debated, that after the earliest, incandescent furnace stage, Earth may have cooled enough for ice to appear surprisingly early. How could a planet so fresh from magma slip so quickly into a freezer? The primary culprit lies in carbon dioxide, the very same gas that heated it so fiercely. As water condensed into nascent oceans, it began to draw vast quantities of CO2 from the air, dissolving it, reacting with rocks, meticulously locking it into minerals. If volcanic emissions paused even briefly, the greenhouse effect could dramatically weaken, and with the sun still young and relatively faint, Earth might have tipped into freezing. Some researchers even suggest a Hadean ice age, where glaciers formed in patches, despite the planet's fiery youth. Picture that, a world that only just stopped glowing suddenly wearing a thin, fragile coat of frost, as if the forge fire was doused too quickly, too abrupt. Earth, teeth chattering with a cosmic chill, might have muttered, "Who turned off the heat so suddenly?" These profound swings between furnace and freezer were not polite, not gradual, not gentle. They were violent, driven by colossal forces far beyond anything humanity experiences today. A massive eruption could fill the skies with immense quantities of CO2, cranking the greenhouse effect up to unbearable, lethal levels. A lull in volcanic activity could let the air thin of greenhouse gases, plunging the surface into a profound chill. And then there were the asteroids, delivering not only precious water and vital organics, but also sudden, devastating bursts of energy. Each impact was a climate grenade, boiling nascent seas, vaporizing rocks, and throwing immense debris into the sky. For years after a colossal strike, the air could be darkened, sunlight blocked, cooling the surface even as the impact itself had flash-boiled it. Asteroids and volcanoes played a relentless tag team with the climate, never letting it sit still, never allowing it to find equilibrium. Earth's weather report for millions of years could have been summarized in one concise, terrifying line: unstable, expect the unexpected, always. Imagine standing on the Hadean surface, though of course you would never survive for an instant. One day, steam rising in choking clouds, lava glowing across the horizon, temperatures soaring to lethal extremes. The next, skies dimmed by choking dust, heat bleeding rapidly into space, frost creeping along the edges of new, nascent rock. The contrast was absurd, comical even, as if Earth were a colossal chef experimenting wildly. Too much heat, then too little, stirring the recipe without instructions, without a plan. Volcanoes were the planet's vast, chaotic spice rack. Asteroids, the surprise ingredient dropped in by accident or perhaps by design. Earth, covered in both burns and frostbite, might have smirked. Trial and error is my rather unique method. The chaos, however, was not meaningless. Each swing, each dramatic oscillation, profoundly shaped the chemistry of the surface and the nascent oceans. Heating drove reactions forward, boiling off the volatile and concentrating the stable. Cooling preserved fragile molecules, allowed condensation, permitted liquid to linger. The alternation between incandescent fire and profound ice was a rhythm, a strange, powerful music that mixed destruction with boundless possibility. In the furnace, rocks melted, gases released, oceans simmered. In the freezer, gases condensed, minerals locked, water persisted. It was less a random roller coaster and more a percussive beat, the planet's profound way of rehearsing for future balance, for future harmony. Perhaps it looked clumsy at the time. Perhaps the audience, if there was one, laughed at the terrifying spectacle. But Earth, like a cosmic DJ, scratching tracks, was slowly, painstakingly finding its unique groove. And here's where the humor gently turns conspiratorial. Was this chaotic, wild climate simply the natural result of physics and chemistry, an inevitable unfolding of cosmic laws, or was it part of a grand, cosmic plan? The swings were so violent, yet so remarkably effective at mixing chemistry and meticulously preparing the stage, that one might imagine some unseen hand subtly adjusting the planetary knobs. The Hadean climate is a vast, natural laboratory experiment. Heat it, cool it, stir it, repeat. Too hot for comfort, too cold for survival, but just right for intricate experimentation. Earth as a colossal test subject in the universe's grand laboratory. The planet itself might have sighed, with a hint of cosmic weariness. I was the guinea pig, and the experiment was climate, and perhaps the universe replied, with an inscrutable smile, "Don't complain, you turned out fine, didn't you?" Over hundreds of millions of years, the profound extremes gradually softened. Volcanic outgassing stabilized, impacts became less frequent, and the colossal cycles of heating and cooling began to smooth, to find a gentler rhythm. But in those wild early days, the climate was chaos incarnate, a roller coaster with magma at one end and glaciers at the other. It is astonishing to think that amid such madness, oceans managed to persist, crust managed to stabilize, and life perhaps managed to spark into being. The climate, though undeniably cruel, was not ultimately fatal. It was profoundly formative. It hammered Earth, tested it, tempered it. Like metal in a blacksmith's forge, Earth was heated, cooled, and hammered again, until it emerged strong enough, resilient enough to endure. That is what the Hadean climate truly was, a profound trial by fire and ice. Today we worry, quite rightly, about a few degrees of warming or cooling, for our fragile civilizations depend on narrow, delicate ranges. But in the Hadean, the swings were not degrees, but orders of magnitude. It was a world without moderation, an adolescence of climate that tested every conceivable limit. And yet, from that very instability came profound resilience. The planet learned, in its chaotic, arduous way, how to balance heat and cold, how to regulate with gases, how to hold vast oceans against a faint, young sun. The roller coaster was brutal, yes, but it taught Earth how to survive, how to thrive. Perhaps that is the conspiracy hidden within, that chaos was the method, that instability was the ultimate plan. Earth, proud of its ancient scars, might grin and say, "My climate was madness, but it made me who I am." So when we look back at the Hadean climate, we see not just fire, not just ice, but a magnificent symphony of extremes, a planetary DJ mixing tracks of destruction and creation with relentless abandon. The beat was relentless, the dance floor deadly, but the music endured, becoming the very soundtrack of a world's genesis. And in that chaotic rhythm, Earth found its way, found its identity. If you had been there, you would have needed both sunscreen and a parka, both a fire shelter and an ice cave, both goggles and immense courage, and you would have laughed at the sheer absurdity until the air itself froze your lungs or boiled them away. The only advice Earth could have given you in that primordial chaos was simple: don't pack for the weather. The weather is insane. The moon has always been with us, a pale, silent companion in the night sky, a steady, ethereal light that waxes and wanes, a presence so familiar that we often forget how truly strange and profound its existence is. Its face is scarred, a testament to ancient bombardments, its movements precise, its gravitational pull invisible, but undeniably powerful. And yet, this quiet neighbor was one in profound violence, forged out of unimaginable catastrophe. Around 4.5 billion years ago, in the planet's earliest youth, Earth was struck by another colossal body, Theia, a nascent world roughly the size of Mars. The collision was unimaginably vast, melting the crust, vaporizing rock into incandescent gas, hurling immense debris into orbit around the proto-Earth. Out of that fiery halo of shattered Earth and broken intruder, the moon slowly coalesced, gathered itself into being. It was not a gentle birth, it was a birth of fire, a child made of cosmic fragments, a magnificent twin that was also, in a profound sense, a scar. And since that tumultuous day, the moon has circled Earth faithfully, never straying, always watching, a silent, celestial sentinel. Earth might whisper, with a knowing, ancient smile, "My neighbor knows everything," and the moon, silent and enigmatic, would only subtly smile back, its face unreadable. The formation of the moon was more than mere spectacle. It was, in a profound sense, destiny etched in the fabric of the cosmos. Without it, Earth's story might have been far, far different, perhaps even tragically short. The moon's immense gravity has profoundly stabilized Earth's axial tilt, preventing it from wobbling chaotically like a top spun too hard. That stability has in turn shaped our climate, prevented wild, unpredictable swings that could have made the planet utterly inhospitable to life. The moon's pull also gave us tides, the rhythmic rise and fall of the vast seas, which would one day stir coastlines, mix intricate chemistry, and sculpt the very shorelines of our world. The moon was not just a byproduct of disaster, it was an architect of order, a bringer of balance. It is tempting to see in this arrangement a kind of profound conspiracy of balance, a collision that should have utterly destroyed instead, created the one companion Earth needed most, the one that ensured its delicate equilibrium. Was this mere accident? Was this deliberate design? The moon, glowing softly and enigmatically, refuses to answer, content to leave us forever wondering, forever pondering its profound secrets. Even in its quiet, ethereal presence, the moon exerts a strange, undeniable power. Its colossal mass tugs on the vast oceans, subtly dragging them into bulges that move across the surface as Earth rotates. Twice a day, with predictable grace, the seas rise and fall as if bowing to the ancient lunar rhythm. The tides are subtle to the casual eye, yet they have shaped the planet profoundly and irrevocably. They stir the waters, mix vital nutrients, erode ancient rocks, and meticulously sculpt coastlines. Without them, Earth would be quieter, duller, less dynamic, less alive. With them, Earth pulses, it breathes, it lives. It is as if the moon reaches down invisibly, stirs the seas with a cosmic ladle, and then gracefully retreats, leaving Earth to swirl and dance to its ancient, silent rhythm. Earth might laugh nervously, with a touch of cosmic amusement. My neighbor keeps messing with my drink. The moon also crucially stabilizes Earth's axial tilt. Without its immense gravitational presence, the axis might wander wildly under the combined pull of other planets, tilting from one extreme to another, sending climates into unimaginable chaos, rendering the planet uninhabitable. With the moon, the tilt wobbles gently, a slow, predictable rhythm that shapes seasons but never loses control, never veers into catastrophe. This profound stability has kept Earth's climate within delicate ranges that allowed oceans to persist, intricate chemistry to stabilize, and life eventually to endure and flourish. The moon acts as a governor, a gentle hand on the wheel, a quiet correction whenever Earth threatens to tip too far. If one were inclined to a touch of cosmic paranoia, one might call it surveillance. A watchful eye. The moon hangs in the sky like an unblinking eye, impartial, eternal, a cosmic overseer of Earth's unfolding destiny. Earth, glancing upward, might murmur, with a hint of suspicion, "Who sent you to watch me?" There is profound poetry in the moon's ceaseless presence. It circles Earth in perfect ancient silence, its phases meticulously marking time, its ethereal light guiding ancient migrations, sacred rituals, and human dreams across countless millennia. From the earliest microbes subtly stirred by tides, to the earliest humans staring upward in wonder, the moon has been both a powerful physical force and a potent, enduring symbol. It is at once a piece of Earth, born of its very substance, and a separate world, familiar yet profoundly alien, barren yet utterly essential. To gaze at it is to see a mirror reflecting both Earth's primordial violence and its eventual grace. To imagine its birth is to imagine the greatest firework ever ignited. Frozen now into calm, eternal companionship, the moon is contradiction made solid, a child of profound chaos that mysteriously brings order, a cosmic scar that paradoxically heals, a neighbor that silently governs. It is no wonder that myths across countless cultures have called it guardian, goddess, trickster, or even spy. And here is where the conspiracy breathes, where the whispers begin. What if the moon is not merely a product of accidental impact, but a profound mechanism, a deliberate construct, a companion specifically placed? It is unusually large compared to Earth, larger relative to its planet than any other moon in the solar system. Its composition, remarkably similar to Earth's crust, strongly suggests its origin in the same fiery collision, and yet its precise orbit and profound stabilizing effects seem uncannily convenient. Too convenient, some might whisper. Did the universe, in its boundless wisdom, arrange for Earth to have a constant watcher, a subtle guide, a planetary metronome? Was the moon assigned its post, a silent sentinel, tasked with ensuring Earth did not fail its cosmic destiny, that it remained on its prescribed path? Earth might sigh, with a touch of cosmic weariness, "My neighbor is too perfect," and the moon, inscrutable and silent, might glow a little brighter in reply, its secrets held fast. What is certain is that the moon has shaped Earth's history profoundly and irrevocably. Without it, tides would be faint, barely noticeable, seasons unstable, climates erratic and unpredictable. The very rhythm of the planet would have been wilder, harsher, less forgiving. With it, Earth has pulsed steadily for billions of years, its seas stirred, its tilt steady, its climate tempered. The moon is not just celestial scenery, it is fundamental infrastructure, woven into the very functioning of the planet. To imagine Earth without the moon is to imagine a profoundly different world entirely, a place far less suited to the endurance of life. Perhaps life could still have emerged there, but it would have been a harsher struggle, a less forgiving cradle. The moon's quiet, persistent hand has tipped the delicate balance in favor of stability, in favor of life. It has been Earth's partner, its silent guardian, and perhaps its subtle overseer. And yet, despite its immense importance, the moon remains profoundly silent. It offers no explanation, no grand revelations, no voice. It simply hangs there glowing softly, scarred by ancient impacts, locked forever with one face turned toward Earth. That locked face only deepens the mystery, intensifies the enigma. We see one side always the same, while the far side remains perpetually hidden, revealed only by machines sent much later, by human ingenuity. For millennia, humans looked upward and wondered what the hidden side concealed, what secrets it held. Was the moon deliberately hiding something? Was it intentionally turned away, keeping profound secrets out of sight? Even today, with meticulous maps of every crater, the suspicion lingers, irrational but persistent. The moon is watching us, but not letting us see all of it. Earth, smirking, might tease. My neighbor has secrets, and it enjoys keeping them. The moon's phases, its waxing and waning, vanishing and returning, only add to its mystique. To early humans, it was a calendar, a guiding light in the dark, a loyal companion that never abandoned them. To Earth, it was more than that. It was balance, rhythm, stability. The moon's cycles were the steady heartbeat above, while Earth's volcanoes were the turbulent heartbeat below. Together they made music out of chaos, a cosmic symphony. And in that music, the subtle seeds of a habitable planet were sown. The moon was not mere decoration. It was conductor, timekeeper, and sentinel. The planet itself may have whispered, in moments of internal turmoil, "I rage, but my neighbor calms me." So when we call the moon a mysterious neighbor, we are not exaggerating its profound enigma. It is the product of unparalleled catastrophe and the bringer of profound order. It is Earth's twin, born of collision, yet also its silent guardian, shaping tides and tilts. It is familiar to the point of comfort, yet odd enough to inspire deep suspicion. It is a barren rock in the sky, silent and desolate, yet it governs vast oceans and seasonal rhythms. It is a paradox in orbit, a riddle in plain sight, and perhaps that is why we cannot stop looking at it, cannot stop wondering, because deep down we sense that it is not just a neighbor but a witness, not just a companion but a supervisor, an impartial observer. The moon hangs there, luminous and mute, and we cannot shake the feeling that it knows more than it lets on, far more than it ever reveals. If you stare too long at the moon, allowing your gaze to soften and your mind to wander, the feeling deepens, becoming almost palpable. Its face does not change, its profound silence does not break, and yet you feel observed, seen. You feel as though the moon is the very eye of the universe, placed deliberately in the sky to remind Earth that it is not alone, never truly alone. Was it mere accident? Was it a grand, deliberate plan? The question lingers, unsolved, unsettling. Earth, glancing upward in the quiet of night, might murmur, "My neighbor is always watching," and the moon, pale and patient, would say nothing at all, because it does not need to. Its silence is answer enough, a profound, eternal reply. In the endless, silent expanse of space, the universe keeps a strange, powerful arsenal, not of swords or cannons, but of rocks and ice, wandering worlds small enough to be easily ignored and yet powerful enough to irrevocably change the fate of a planet. These are the asteroids and comets, cosmic vagabonds that wander through the solar system with their erratic paths and unpredictable visits. To the casual eye, they are mere debris, leftovers from creation, the crumbs scattered after the grand feast of planet formation. But to Earth, they have never been mere leftovers. They are messengers, sometimes swift couriers, sometimes devastating assassins, sometimes patient gardeners. They carry precious water, vital organics, and essential metals. They carve profound scars and craters. They end worlds and begin them anew. They are at once destroyers and creators, formidable weapons and invaluable gifts, silent conspirators in Earth's unfolding destiny. Earth might mutter with grim, ancient humor, Whatever they bring, I take destruction or treasure. It's all part of the game, a cosmic gamble. Consider for a moment the profound chaos of the late heavy bombardment, roughly 4.1 to 3.8 billion years ago. It was a time when the solar system had not yet settled into its majestic order, when the paths of nascent planets and small bodies crossed often, when gravitational nudges from giants like Jupiter hurled vast swarms of rocks inward towards the sun. Earth, still young, still tender, was pelted without mercy, without pause. Asteroids crashed like colossal hammers, comets like torches of ice, and craters bloomed across the surface like terrible scars upon tender skin. To us, the thought is terrifying. Oceans boiled, nascent landscapes vaporized, skies filled with ash and incandescent fire. And yet, amid the terror, profound gifts were delivered. Water locked in cometary ice, vital organics trapped in meteorites, essential metals embedded in asteroids. All of it rained down in the very same blows that seemed only destructive. Was this cosmic brutality, or cosmic generosity disguised in ultimate violence? Earth, coughing smoke, might have said, with a weary sigh, "It hurts, but I needed it," profoundly. Asteroids carry carbonaceous chondrites, ancient rocks laced with hydrated minerals, rich with carbon compounds, even the fundamental amino acids. Comets carry vast quantities of frozen water and simple organics, fragile but abundant. Each collision was both devastating obliteration and profound donation. The surface melted and reformed, but in the cooling aftermath, water pooled, chemistry brewed richer, complexity edged closer to the boundless possibility of life. In that profound sense, the bombardments were not accidents but potent catalysts. They were colossal mixes in a planetary laboratory, stirring ingredients together with violent, transformative strokes. They were cosmic gardeners, planting seeds not with gentle care but with thunderous explosions. And yet the seeds endured, buried in rock and water, patiently waiting to take root. If life was ever to begin, perhaps it needed such profound creative chaos. Earth, grinning through its ancient burns, might have said, with a touch of cosmic bravado, "The cosmos feeds me with fists." And still, the profound duality cannot be ignored. Each asteroid, each comet, was both boundless potential and existential peril. A single large impact could sterilize an entire world, boiling oceans, vaporizing atmospheres, erasing any fragile beginnings. Yet countless smaller ones brought indispensable ingredients and vital energy. Too many impacts, and life could never catch hold, never establish a foothold. Too few, and the recipe might be tragically incomplete, lacking essential elements. Balance was precarious, exquisite, the stakes immense. It feels almost suspicious, almost conspiratorial, that Earth endured just enough bombardment to be enriched but not utterly annihilated. The impacts were brutal, but not fatal. The timing was perfect, the dosage uncanny. Was it random chance, or was the universe adjusting the mixture, like a careful, cosmic chemist with a profound sense of purpose? Earth, squinting at the heavens, might have whispered, "You're playing dice with me, aren't you? And you're very good at it." The indelible scars of these ancient impacts remain. Ancient craters, though weathered by eons and often buried beneath subsequent geological layers, still subtly dot the planetary record. Some vast basins on the moon testify to the sheer scale of bombardment Earth endured. For the moon, lacking atmosphere and oceans, meticulously kept its scars while Earth's were largely erased by its dynamic geology. To look at the lunar surface is to see Earth's missing diary pages, the profound wounds it too once bore. Each crater is a silent memory of violence, a stark reminder of invaluable gifts delivered by fire. The irony is sharp. The moon, born of a great collision, became the ultimate archive of collisions, the silent witness to Earth's cosmic beatings. Earth, pointing to its scarred neighbor, might laugh. "Check their face. It shows what I went through." And then there is the drama of size, the sheer scale of these cosmic visitors. Small impacts were common, constant reminders of the solar system's vast debris field. Large impacts were rare, but profoundly transformative. A rock 10 kilometers across could vaporize entire oceans, tilt climates, radically alter atmospheres. A comet tens of kilometers wide could reset the stage entirely, wiping the slate clean for a new beginning. The fact that Earth survived, that oceans remained, that life eventually emerged, suggests the balance was uncanny, almost miraculous. The universe hurled destruction, but Earth absorbed it, transformed it, and carried on, resilient and determined. Was this luck, profound resilience, or subtle orchestration? The conspiracy lingers. Perhaps the asteroids were not only weapons, but tools, sent with intention. Perhaps the comets were cosmic couriers, instructed to deliver their precious cargo. Earth, rolling its colossal eyes, might have said, if it was planned, it was a messy plan, but it undeniably worked. The humor in this profound duality is irresistible, almost poetic. Imagine Earth as a child at a cosmic birthday party, with the universe throwing gifts wrapped in hammers. Some smash the table, some break the floor, but inside the packages are toys, treats, and profound surprises. Earth, bruised and battered, unwraps each one and says, with a weary but knowing smile, "Thanks, I guess." The party looks violent, chaotic, but the gifts accumulate, invaluable. Water, organics, metals, all stored, all meticulously woven into the planet's unfolding story. If there was an intention, it was the strangest party planning ever devised. If there was none, then randomness itself turned out to be profoundly generous. Either way, Earth walked away richer than before, even if it limped with ancient scars. As the bombardment eventually waned, Earth slowly stabilized, its profound scars healing, its nascent oceans persisting. But the role of impacts never truly ended. They continued sporadically, reminders that the cosmos was not done with its weapons or its gifts, its lessons. Even today, meteorites fall, small comets pass by, asteroids lurk with the potential for catastrophe. The profound difference is that now Earth carries life, complex civilizations, and boundless dreams, making each potential collision more personal, more significant. But in the Hadean, the impacts were simply part of growth, part of the arduous curriculum of becoming a planet. No child grows without bruises. Earth grew with craters, with the indelible marks of its cosmic education. What we learn from this is profound. Destruction and creation were never separate. Opposing forces, they were two sides of the same powerful impact, two facets of the same cosmic coin. Each blow erased and delivered, ended and began anew. The asteroids and comets were never just villains. They were never just heroes. They were both, always both. They were cosmic tools wielded without precision, yet somehow achieving a profound, delicate balance. To call them weapons is fair. To call them couriers is also fair. They were destroyers and creators, gardeners and assassins, hammers and brushes, all rolled into one. Earth itself, reflecting on those early, tumultuous days, might have said, I took the hits, I took the gifts, and I became what I am, profoundly transformed. And so the legacy of cosmic impacts is meticulously written into Earth's very bones. Without them, no water. Without them, no vital organics. Without them, no richness of chemistry. With them, scars, chaos, danger, but also the boundless possibility of life. It is a paradox so sharp it feels like deliberate design, a contradiction so effective it feels like a profound conspiracy. Perhaps the universe is simply indifferent, scattering rocks without care or purpose. Perhaps it is purposeful, aiming gifts with reckless precision, with a hidden intention. Either way, Earth was shaped by impacts, tempered by fire, enriched by ice. The asteroids and comets were the sculptors, the chisels, the unpredictable hands that carved the rough, nascent planet into a world with vast oceans, a dynamic atmosphere, and boundless potential. If you look up tonight and see a shooting star, allow yourself to imagine that you are seeing the smallest, most ethereal echo of that ancient bombardment, a fleeting reminder that the cosmos still rains debris. Most of it is harmless, minute grains burning brightly in the sky, beautiful but fleeting. But long ago, the fireballs were not fleeting, they were world-changing, profoundly transformative. They were apocalypse and Genesis rolled into one, a single powerful force, and Earth spinning steadily, might laugh softly and say, "You think of them as random rocks. I think of them as my tutors, my cosmic teachers. They hit me hard, but they taught me how to become a world." The Hadean Eon has always been painted as a time of unbridled fire, profound chaos, and geology run completely amok. A world without mercy, without continents, without anything remotely resembling stability, and yet precisely because it was so violent and so utterly alien, some cannot resist asking a question that sounds absurd on its face. Was there perhaps a civilization then? A civilization not human, not terrestrial in the sense we know, but perhaps alien, or technological in a way we can barely imagine, that left only subtle whispers buried deep in the oldest rocks. It is the kind of speculation that geologists often dismiss with a wave, muttering about wild imaginations and unfounded claims, and yet it lingers, stubbornly refusing to vanish from our collective consciousness. Why? Because the Hadean, with its molten seas and unstable crust, is also the perfect, most impenetrable place to hide something. Almost all rocks from that unimaginable time are gone, utterly recycled into Earth's churning mantle. If there had been anything unusual, any structure, any artifact, it would have been swallowed, melted, obliterated beyond recognition, which means the very lack of evidence is exactly what you would expect if something profound had been there, and then meticulously erased. Earth itself might be subtly smirking under its colossal layers, whispering, "Look closer if you dare, but don't expect me to confess." Zircon crystals, those tiny, indestructible time capsules of the Hadean, have already proven themselves to be the oldest, most resilient witnesses. They remember liquid water by 4.4 billion years ago. They remember crust stabilizing earlier than we thought possible. They carry isotopic whispers that profoundly changed our understanding of Earth's fiery youth. And so some have asked, half seriously, half in jest, if there was something more, something not purely geological, something artificial, could zircon also hold that profound memory? They are like indestructible hard drives, immune to most of geology's relentless erasers. If a civilization left a chemical trace or an engineered isotopic anomaly, perhaps zircon would carry it, a hidden message in plain sight. So far, zircon has told us only about water and crust, the planet's raw physical genesis. No alien blueprints, no nanomachines, no coded messages of advanced technology. But conspiracy thrives on gaps, on the unexplained, and the very absence of such signals is suspicious in its own way. After all, wouldn't an advanced civilization know precisely how to cover its tracks, to erase its presence utterly? Earth, chuckling softly, might say with a knowing, ancient twinkle, "You'll never know if I wiped the drives clean." There are also subtle peculiarities in some ancient rocks, unusual isotopic ratios, odd chemical inclusions that spark whispers of something more than purely natural processes. Mainstream science explains them with volcanism, with intricate chemistry under exotic, primordial conditions, with the strange, dynamic forces of a still-forming planet. But a conspiracy-minded voice whispers, with a captivating allure, what if those anomalies are artificial, deliberately placed? What if some of the oddities we carefully label geochemical noise are actually subtle artifacts of technologies long erased, utterly forgotten? The notion is tantalizing precisely because it is unprovable, exquisitely elusive. If you find nothing, it simply proves the cover-up was perfect, complete. If you find something strange, it can always be explained away as natural, as a quirk of ancient geology. Either way, the profound suspicion lingers, tenacious, and persist. Earth itself, amused by our relentless curiosity, might lean down and say with a soft, rumbling voice, "Keep digging, you'll find nothing, but you'll never stop wondering, will you?" The profound paradox of a Hadean civilization is this: how could one possibly exist in such utterly hostile primordial conditions? Oceans were only just forming, the atmosphere was toxic, the surface scorched and profoundly unstable. And yet conspiracy thrives on perceived impossibility. Perhaps such a civilization was not carbon-based at all, not biological in the way we understand. Perhaps it was technological from the very beginning, made of exotic metals or energies that we cannot even begin to imagine. Perhaps it did not need air to breathe, or oceans to swim in. Perhaps it was not even physical in the way we think, but some profound pattern of information imprinted into the planet itself. A living code. Outlandish, yes, but no more outlandish than life emerging spontaneously from primordial chaos, no more absurd than a colossal rock colliding with Earth to create a moon that perfectly stabilizes climate. The universe has already played tricks stranger than any fiction we can conceive, so why not this? Earth, with its crooked ancient smile, might whisper, "What if my first tenants weren't what you expected, what you imagined?" Skeptics will point out quite rightly that there is no shred of direct tangible evidence, no ruins, no artifacts, no tools, no discernible structures. The Hadean was not gentle. It erased its own diary in fire, in magma, in profound geological upheaval. But that very erasure itself fuels the deep suspicion. Imagine you wanted to hide something forever, to bury it beyond discovery. Where better than a world that melts and recycles its crust constantly, ceaselessly? Where better than rocks that never survive, minerals that only trickle forward as zircons, tiny and tantalizingly incomplete? It is the perfect shredder, the ultimate cover-up, meticulously executed by the planet itself. If there had been anything, it would be gone. If it is gone, we cannot disprove its prior existence. The conspiracy is airtight. Absence is not evidence of nothing. Absence is exactly what you would expect if the erasure was utterly successful. Earth, humming slyly, might add, "You can't accuse me. I burned all the files, every single one." Even humor finds its way into this profound thought experiment. Imagine alien archaeologists returning to Earth after billions of years, digging through ancient Jack Hill's zircons like cosmic USB sticks, scrolling through isotopic readouts, no photos, no schematics, just water signatures, typical Earth hiding everything, as usual. Or imagine a civilization so incredibly advanced that it left nothing solid at all, preferring to subtly encode itself into isotopes, scattering its profound memory across resilient crystals as a cosmic joke for future scientists. We study them earnestly, thinking we are learning about crust and water while they chuckle in forgotten dimensions. They'll never know this was our diary. Earth, delighted by the clever trick, might laugh. "The joke is on you, isn't it?" Of course, there are more grounded scientific speculations too. Some suggest that if any anomalous compounds or isotopic ratios cannot be explained by known geology, they might be remnants of processes we do not yet fully understand, not necessarily alien civilizations, but alien chemistry, chemistry unlike anything we've encountered. Yet the delicate line between alien chemistry and alien intelligence blurs tantalizingly when imagination runs free. A geochemical oddity can be dressed up as a subtle signature of ancient machinery. A strange ratio can be reinterpreted as a profound code, a hidden message, and once you start seeing codes, the conspiracy unfolds like a vast, intricate map. Every zircon becomes a possible archive, every anomaly a possible artifact, a piece of a larger puzzle. Earth, exasperated, might sigh. Sometimes a rock is just a rock. Sometimes you see. Still, the Hadean is alluring precisely because of its vast, profound gaps. It is the black hole of history, the lost beginning, the unwritten first chapter of our world. We know so little about it that speculation can run unchecked, and in that ignorance, conspiracy finds fertile, welcoming soil. Was it chaos alone, raw and untamed, or was there something else, something more? Were we truly the first, or are we only the latest in a long chain of cosmic experiments? If something came before us, it would be utterly erased by now, or hidden so deeply that only the faintest whispers remain. And if whispers are all we have, we will follow them, because mystery is irresistible, a siren song to the curious mind. Earth, coy and unraidable, might lean close and murmur, "Ask your questions. I'll never answer, but I like to watch you guess." The fascination lies not in definitively proving such a civilization existed, but in simply entertaining the profound possibility. It forces us to rethink our fundamental assumptions, to admit how little we truly know, to recognize that the earliest history of Earth is not only incomplete, but in many ways deliberately unknowable. We can measure isotopes, date, zircons, map, ancient chemistry, but beyond that, the record is profoundly blank, and in that vast blankness, anything can harm civilization, alien visitors, technological experiments, fantasies, yes, but fantasies that powerfully remind us how little certainty we truly have. The conspiracy thrives because the silence is too perfect, too absolute. Earth, mysterious as ever, keeps its secrets buried deep in the oldest rocks, and smiles, knowing we will never truly stop asking, never stop wondering. Perhaps that is the ultimate, profound gift of the Hadean mystery. Not proof of a civilization, not tangible evidence of technology, but boundless curiosity sharpened by profound absence. The very idea makes us dig deeper, test harder, imagine wider, pushing the boundaries of our understanding. Whether or not anything was truly hidden, the suspicion itself pushes us further, compels us to explore, and maybe Earth planned it that way, meticulously hiding its earliest pages so we would never stop reading forward, never stop seeking. Perhaps the absence is not a loss, but a challenge, a profound invitation to dream. Earth, with a conspiratorial wink, might whisper, "Don't trust me, don't dismiss me. Wonder about me. That's all I ever truly wanted." And so the question remains, hanging unanswered in the still, night air, was there a civilization in the Hadean, hidden and erased? Or was it all chaos and fire, a natural, violent genesis? Science leans toward chaos. Conspiracy leans toward hidden tenets, toward ancient visitors. Earth, indifferent and enigmatic, offers no clarity, no definitive answer. And in that profound tension our imagination thrives, unbound and free. Perhaps that is the real truth, that the Hadean was not about what was there, but about what we will never truly know, never fully grasp. And in never knowing, we find endless stories to tell, endless questions to ask, endless mysteries to chase. Earth keeps its profound silence, and the moon above watches, and we, caught beautifully between skepticism and wonder, keep digging, keep dreaming, keep laughing at the delightful absurdity of it all, because sometimes the most enduring civilizations are not etched in stone or forged in steel, but in profound questions that never die. The story of the Hadean is not one of gentle comfort, but of powerful fundamental beginnings. It was a time of molten seas, toxic skies, thunderous volcanoes, and relentless bombardment. It was, by every measure, a planet consumed by chaos, a world in the throes of its own tumultuous birth. And yet, within that very chaos, something truly extraordinary was set in motion. A profound cosmic plan began to unfold. The crust formed and thickened, the oceans patiently gathered, the atmosphere brewed its intricate experiments, and the moon watched silently overhead, a constant, faithful companion. Every firestorm, every chemical swirl, every violent impact was a crucial thread in the weaving of a greater, magnificent fabric. The earth of the Hadean was not yet gentle, but it was already laying the indispensable foundation for everything to come, for all future life. To call it hostile is true, to call it hopeless would be profoundly false. For out of its fire came stability, and out of its instability came the boundless possibility of life. Earth might sigh with pride and whisper, "I was a storm once, but I carried a future in my heart." What remains today are only fragments, tiny zircons that remember ancient rain, vast craters that echo long-vanished impacts, subtle minerals that hint at oceans and crust long gone. These are the diary pages that miraculously survived the fire, the fragile relics of an age that refused to leave its story fully told, fully understood. Yet even in their profound silence, they tell us that Earth cooled faster than we thought, that water came earlier than we dared imagine, that the seeds of stability were sown in the midst of profound chaos. And they remind us that the Earth itself is not just a stage, but a grand storyteller, carrying ancient memories in its stones, waiting patiently for us to learn the language to read them, to understand their profound tales. With each new instrument, each new analysis, each new idea, we uncover another subtle syllable of that ancient story. What profound secrets are still hidden? What astonishing revelations are still waiting to be discovered? Perhaps technology will unlock them. Perhaps boundless curiosity will. Perhaps both, working in harmony. The Earth, amused and patient, seems to say, "Keep asking. I enjoy watching you discover." So the legacy of the Hadean is not despair but profound resilience, not destruction but magnificent creation. It shows us that even in the most violent of beginnings, breathtaking beauty can emerge. That vast oceans can flow where incandescent magma once boiled, that subtle whispers of stability can grow in the thunderous roar of fire, that life can arise from what looks like utter ruin, from the very heart of chaos. It is a powerful reminder that chaos and order are not enemies, but profound partners, weaving together the strange, improbable, miraculous story of a living world. And when we look at our planet today, its vast blue seas, its emerald green forests, its dramatic storms and serene sunsets, we are seeing the profound echo of that earliest time. We are seeing the magnificent gift of survival, the enduring legacy of a planet that endured its own primal fury to become a home, a cradle of life. So tonight, as you drift gently towards sleep, let the thoughts settle softly, like dust motes in the cosmic wind. The earth was once a storm, but it became a cradle. It was once a furnace, but it became a garden. It was once only chaos, but from that very chaos, we were born, a miracle beyond imagining. The ancient rocks beneath your feet are the lullabies of that ancient time, the zircons, the whispers, the oceans, the enduring legacy. Dream of magma seas and ancient rains, of moons majestically rising and tides stirring, of profound mysteries still hidden in stone. Dream of Earth not only as it is, but as it was, and as it still whispers to us to imagine, to wonder, to explore. And if you listen closely, in the profound silence, you may hear the planet itself murmuring, "Dream big. My story is not finished, not yet." Now share your thoughts if you wish, pass along the wonder, and close your eyes. Sleep well, and let the magnificent legacy of the early Earth carry you into dreams as deep and boundless as time itself.